Today we're going to be checking out this printer. I got this in for review from LDO Motors, and I got it mostly built in one stream, but I didn't quite finish it. So today we're going to finish it up, hopefully. I'm not sure if I'll be able to do it, but we're at least going to try. So I need help from you, the audience, to figure out how to put this thing together, because I'm not a pro Voron builder, and I think I got everything plugged in, but we're just going to have to go through it together and see if we can get it printing. Alright, and I'm going to turn some lights on in here and get everything all ready, but I'll train the camera so far. So I assembled the Core XY stage, so this all looks good. I got the bed installed, and I don't want to hear any complaints anymore. I'm done with you complainers out there, you bad internet haters. But yeah, I'm inside of a building that doesn't get good cell service, and I was trying to use the cellular connection because the Wi-Fi didn't connect. Anyways, that's all boring stuff. Let's get to the interesting business of printing things. So I'm gonna fire up a print on this bad boy over here. So that is the Uri one. EF. You know, I just want to print something, and I can never get the prints to print. It's good. Yeah. I have a whole rant planned on this. Okay, everyone, thank you for joining. So today we're going to be printing, or finishing this printer here. This is the Voron Trident that it's a Voron Trident that LDO sent over to me. So, welcome back. I think everything should be working now. I'll check the internet on my end. I'll see if I can watch my own live stream with the recursive loop. Let's see it. Okay, yeah, I can see myself live on the internet. Okay, that's me. Okay. Cool. Anyways, we need to print out a phone mount so I can attach the phone to a tripod. And then we need to figure out how to get this whole printer assembled. It's mostly finished. I put the frame together, the heated bed and that whole assembly, and the Core XY motion system. The only last parts I need to do is basically the tool head, which seemed really complicated when I got to that step in the last time I was building this. And I was like, you know what, we're going to do this another day. So today's another day, and we're going to do it. Let me find my box of parts. I'm not even sure where my box of parts is at this point. No. I have multiple boxes of parts around here. It's probably in here. Alright, yeah, this looks like Voron parts. I'm not sure how all these go together, so we're going to figure that out. And I think there's like some gears and some fans that I need to put in there. Might need to break out the solder in there. So we're not out of the woods yet. And now would be a great time for an overhead view. So here goes overhead view time, you'll be able to see what I'm working on. Like that. Nope. Nope. There we go. Okay. You can see all this. So I've got my machine screws. Here's a motor. That's probably the extruder that I need. Extruder motor. There's all these parts. Nevermore kit. So there's that. Here's a little shroud there. Here's another one. I still think I'm missing some stuff. So let's see if there's anything in this box. Yeah, here we go. All right, here's the little fan. I'm just gonna get, so I'm watching this live on my computer for monitoring purposes. All right, so parts, no idea how this goes together, and I'm going to take my time so I don't lose my mind, and this might take a while, so bear with me, everyone. Okay, so this is a thing that I need, pretty sure. This also looks like a thing that I need. We got 2 blower fans. They're both LDO motors. They have 2 different fan lengths for the cables. Here's a little heating element. It's using the LDO Voron Revo setup. Okay. Alright, so we have to get all these parts in there somehow. Here's another fan right there. Okay, here's the Y stop and the X stop. Alright, I think I'm gonna need these, so let's get those out. Alright, this... Okay, they don't use sensorless homing on here, and I don't think I've attached the Y and X end stops yet. So I'll have to deal with that. I wonder if I can just configure it to use sensorless homing. Maybe some of you Voron people in the chat can tell me. Alright, this is what it'll look like when it's finished. There you go. Lovely. That's the official instruction manual. Here's a little bed leveling sensor. Here's a tiny segment of cable chain. This is for a 48-volt power supply, which I don't think I have. on here. I actually have a spare 48 volt power supply laying around, so if I wanted to hook this thing up to run 48 volts, I could. But I don't think I'm going to have to for this build. Here's some lights. I assume these get embedded into the hot end somehow. The print head. Okay, and here's our little limit switches. So I can figure this out. This gets plugged in right here. And then this probably gets attached somewhere up in the top right corner or something. And that's if we decide to use those at all. I'm kind of hoping I can do sensorless homing, so there's less assembly work for me to do. This is a little thing that it uses to do automatic Z-axis offset. These are some 3D printed knives that I made. They're very cool. Watch this. Hold on. Let me scratch some stuff out here. Hold on, I need to stab some stuff over here real quick. Okay, so I got these cool guy knives. So watch this. Hacha! Hacha! They're not sharp or heavy enough to use as throwing knives. Or are they? Hacha! There we go. This is... I need to make a video on printed knives sometime. But anyways, let's get back to business here. So we're putting together this kit. Let me push this back a little so I have some room to work with here. Now, is it just me or is this tremendously overcomplicated? Like, it is not immediately obvious how any of this goes together. Like, I assume this goes here. Maybe? Yeah, this goes here. And I'll see where the bolt holes line up. Maybe like this. Alright. So I guess I can figure out that much. But then you have to constantly consult the instruction manual to see what size bolts you need to be using, which is kind of getting old. Here's all the extruder gear parts, these little gears that I'll be using. But let's get this extruder block put together, at least. Like, okay. So I'm going to open up the instruction manual and we'll see if we can figure out how to do this. Okay, here we go. Here's the Voron 2.4 instruction manual. Like the fact that this manual is 260 pages, this is like reading a novel, except you have to do stuff for each step there. Alright, so this looks like what I need here. This is telling you the wiring for the the hot end. Is there a separate instruction manual for the afterburner and the print head? Oh my gosh. Wow, okay, so that is what's going on here. The freaking hot end extruder has its own documentation that is over 70 pages long. Alright, let's do this. So I'm going to assemble the clockwork extruder first, I think. So I need to start melting some stuff into the things here. Okay, I'll get my soldering iron. Here it is. Okay. I like having a nice cordless soldering iron for this stuff. Just makes things a little bit easier. Now, let's get started with melting plastic pieces together. According to the manual that I just got from the Voron... Oh, this is a Voron 2.4. I need to look at Voron Trident instructions. Hopefully that'll be shorter. Okay, so the Voron Trident assembly manual is 291 pages. And this also has a separate assembly guide for the stealth burner. So, looks like we're going to go to... I thought the Trident was supposed to be easier to put together, but the assembly manual is even longer. Okay, so we're going to have to melt some brass heat set inserts into this. I've got to find my brass nuts. I'm not sure where they are. Okay, we've got some here. These are the ones. Okay, let's start melting some plastic. On the Voron, you assemble all the smaller components. Yeah. Alright. Okay, so let's find all the pieces. I'll start with this one. This one's very recognizable on the manual. Looks like I put one in here. Put one in here. I don't know what the deal is with the heat set insert presses that people developed. Like, I'm not sure why you would need that unless you had some kind of disability. Okay, so I got those two, and then one goes in sideways here. There's no way to make sure that this one's square, you just kind of go for it. Because there's no flat surface for it to set on, it's kind of offset, and then you're pushing it on an angle. Okay, next we've got this piece. Looks like it's got two that go in the front here. One there. And one there. And let me get some better lighting here. I know you guys are like probably blind. There we go, nice and bright. Okay, so got one right there. One right there. One goes in the side here. Oh, jeez. This one goes in at an angle as well. So hopefully that's aligned properly. Alright, then we've got three on the back side. One, two, three. Ta-da, okay. I use the special tips for part of this, and I guess it's kind of nice that way you have less lead contamination if you're using leaded solder, because then you have a different tool for soldering and applying heat set inserts. That makes sense to me. This one, it says the heat set inserts need to be below the surface of the part, so I'm just going to heat them up extra and push them down a little bit further. Okay. Make sure to install it straight. Okay. Well, I'm going to install it as straight as I can, given the circumstances. Ah, yes, Zombie Hedgehog is here. Yes, Zombie is here to defend the special heat set insert tips. Heat presses go in with guesses. All right. Let's scroll down a little bit. Okay, there's another heat set insert that goes in over here. I've asked this question before, but honestly, how much do you think it would cost if you were to mass produce the Voron designs and sell them as pre-assembled printers, with how labor intensive they are? Like if I offered you like, hey, I want to buy a printer from you, I want a Voron, how much is it going to cost me if you just give me a printer? All right, one there, and then another one goes in the side here. This one is almost impossible to press in straight because this plastic piece is in the way, so you're kind of bumping into it a little bit while you're pressing it in. But, okay. Oh, sorry, you guys haven't been able to see most of this here. This will be better, right over there. Boom. Now you've got a panoramic view of my messy desk. All right, and then the cable chains, we got to press some more stuff in there. Wow. There's all sorts of little parts I need to put heat set inserts into. Bet I have to put more on this. And then there's a little extruder arm. Okay, time to dig into my bag of parts. I have some bags of parts around here. I don't even know if I have the right version of these parts, by the way. I just got a giant bag of parts. I think this is one of the pieces that it wanted me to use. What is all this? Are any of these parts that I need? Maybe this one? That looks useful. No. Okay, so I think I found something. Maybe this one. Okay. So I think this one might be useful. There's a couple pieces in here that I don't recognize at all. I just don't think I have them. Okay, so so I need to figure out where to find this piece so I can print it out. I'm confused what part of this is supposed to be fun. Can someone explain to me when I'm supposed to start having fun with this? Okay, what's going on here? Hey Paul. Paul's joined the chat, Polymorph. Good to see you again. So, I have this part. I know I need this one. I got these two pieces, that's good. I need to get the... See, like it says I need this part, but there's no part number or anything, so how am I supposed to like figure out where that is if I need to reprint it or something? Which one? What do I do? I just have to dive into the enormous pile of... Let's see, Voron. Yes, bribing myself with snacks. I don't have any good snacks here. But this isn't a Prusa. So idler arm. Alright, I need to find the idler arm. So I'll go to the Voron Trident GitHub. STLs. Oh no, it's not even in the Voron Trident GitHub, it's in the Stealth Burner GitHub. So we'll open that one. STLs. Clockwork 2. Direct drive. I don't know what any of these mean. Latch, shuttle, main body, motor plate. Latch. Okay, I need that. Let me just download all of these. How do I download these? Can you just let me download these all? Or do I have to click each one and then download it? Okay, that's reasonable. Download. 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 Now I hope I got the right version of this main body and then motor plate. I'm just holding it up to the screen. It looks I mean, how is I think I know the answer to this question, but how is Zombie Hedgehog still sane after assembling 5 of these for his custom printer or his tool changer? I don't think he's clearly had to have lost his mind a long time ago to make it through that process. Okay, so I just downloaded 4 parts that I need to print. Let's fire it up. So I'm going to be using my trusty Creality K2 Plus here, which I didn't have to pre-assemble. It just came in a box and I started printing. So there's a big difference there in that experience. Uh-oh. Oh, I was upside down. Sorry, guys. There we go. There's the printer I'll be making these ABS parts with. So here goes. Oh, if I built printers, I might know how these go together. Nice. Real classy. Alright, so I need these parts. I just drag and drop them into Creality print. And then click slice. Oh wait, I need to pick the filament. We'll call this ABS. Okay, and then I just need to load up some ABS into the printer and get started. So let's find my ABS. ABS. Where is the ABS? So I have a slight problem in that I don't know if I have any ABS. I definitely have some glass fiber reinforced ABS though. Hey, great to see you again. I like the new office. Do the glass doors have a... I missed the rest of the comment. I'll look it up on my computer in a moment. ABS. Maybe I don't have any ABS. Okay, here we go. Do the glass doors have an open source hinge? Probably, I would guess so. I mean, on the K2 or on the Uri one? I've got 2 printers with glass doors in here. ABS. Okay, let's see. I mean, doesn't everyone know that ABS releases toxic fumes when you print with it? That doesn't sound ideal. PLA, 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 PLA. This is all PLA. Okay, so that's one issue that I have with the Voron thing, is you have to use ABS. And I don't have any ABS. So what do I do? Just CNC some parts. Okay. Peak, ASA. I have polycarbonate. Does polycarbonate work? Oh yeah, I could do Micro Center. Although that last time I went to Micro Center and printed in my car, it didn't go so well. PTG probably works in the extruder. That doesn't sound like a good idea though. PLA. What is this? Polycarbonate? Does polycarbonate work? Is this PC? Okay, polycarbonate will work. I have one person saying polycarbonate will work, and apparently the K2 Plus should be able to do polycarbonate because it's got a chamber heater, so we'll give it a try. We're just going to load up our Bambu Lab polycarbonate. So if anything goes wrong, we know who we're going to blame. Alright, so I'm going to load this up into the okay. Boston Tech said this isn't going to work, but we're going to prove him wrong. Okay, here we go. Open that up. Turn on this bad boy. Okay, I'm not sure if this is plugged in. Yeah, this might not be plugged in. Take a look back here. Nope. All right, we're gonna unplug the under 5. No, wait, let's just... We can find another power cord down here. There's gotta be another power cord. Here. Plug that in. Alright, is that gonna reach? Yeah, that'll probably reach. Alright. Okay. That's plugged in. Ah, yes. My favorite, Creality, is firing up. Okay, so we're going to unplug this one. We're going to replace it with polycarbonate. Oh, crap. Okay, there we go. Look how smart this machine is. It's automatically feeding its filament. It's not going to be able to recognize it. Although that'd be hilarious if Creality's thing could read the Bambu Lab RFID codes. Although, from what I heard, they're encrypted, so yeah. The idler arm is under the Z motor on the desk. Huh? What do you mean? Nah. There's no way. I think you're hallucinating. Other corner, this one? This is like a game of Where's Waldo for Voron builders. They're like, ooh, I see the part. It's over there. Oh. All right, I'm dropping pieces on the ground. Okay, let's get this Creality thing fired up. Never tested this before. We're gonna switch to polycarbonate. Generic polycarbonate. I could do PPS CF as well, but we'll do polycarbonate. I've always wanted to print with polycarbonate, and now I think I have a machine that can do it. So slice the plate. Print plate, we'll do export. And we'll get that into the flash drive. What do we call this? PC Voron parts. Okay. Then we unplug. We plug it in to this machine up here. It's around here on the side. I'm doing this blind. Maybe I should have put this somewhere else where I can see that USB port a little better. Okay. Okay, here we go. All right, failed command, great. Let's print off PC Voron parts. Where are we gonna feed this from? I think we'll say this one. I think what I need to do before I get started with this is assign the filaments. So this one is generic polycarbonate. Okay. In terms of the color, it's like kind of a clear black. Kind of a smoky clear black. Pretty cool color. All right. And we'll go ahead and print PC Voron parts. It automatically assigns the material because it knows some things. We're going to hit print. All right. Yay. Creality to the rescue. Sweet. Yes. Look at this amazing little printer. What do you guys think of the K2 Plus? Is it living up to expectations? I've only printed PLA with it so far, so we'll see how it handles this high temp material. I've got my, I'm gonna open my door. Make sure I'm not stuck in here with something making nasty fumes. And here we go. All right. Back to business. The business of building this Voron. Okay, let me catch up with the chat. I don't want you guys getting too rowdy in my absence. K2 Kevin loves the K2. It's a fact. He even named himself after it. He loves it so much. Pezliz loves the cloud. Well, you know what? I'm not using the cloud. And I ain't gonna. I just bought something so I never have to use the cloud. Hold on. I'll put this in this bag. Here we go. I got this so I can run a little local network so I can do things over LAN without having to go over the cloud. I just don't like the cloud, everyone. Who wants the cloud? Who actually wants that? You know who wants it? Bambu Lab. That's who wants the cloud. So they can control you. They can see what you're doing and take your data. Okay, so let's see. I guess those, I'll show you how those polycarbonate parts turn out. It says it should be a, let's see, a 43-minute print job. And then it probably needs some time to heat up the chamber. So we'll see how that turns out. Now, what can I do in the meantime? I think I can assemble this motor. I can put like these motor parts together. I can insert these press fit inserts. I'll probably do that when I get the polycarbonate parts out. For now, let's try and progress a little bit on the thing. Wow, Pesla's made $100 selling exclusive models. That's amazing. Okay, now let's go back to the Voron building. And yes, I will go back to the manual as soon as I can find it. Okay. Stealth burner. MR85 bearing. I'm guessing that's one of these little things. No, it's not. I need to find that. I'm dropping parts on the ground. Okay, so I need little bearings. Not these little bearings, they're even smaller. MR85 bearing. Okay, so I just need to find like a little bearing. How hard could that be? Here's a bunch of parts for the clicky probe. Here's my MR85 bearing. So we're going to put this in the main housing. How am I supposed to press that in there? Oh, there we go. I figured it out. Don't tell me. Ah yes, the Revo is a perfect little pressing tool. So that's in there. We need an M3x6 flathead cap screw. So let me just find an M3x6 flathead cap screw. It's my favorite part of this build is searching for tiny random fasteners, because that's how I like to spend my Saturdays. Okay. So how much do you guys want to bet that the K2 Plus is going to work without a hitch? I know there's a lot of Creality haters out there that are going to doubt that it can do the job. Right? You think this isn't going to work. But I'm going to tell you right now, this printer has printed everything I've asked it to so far. And it's busy heating the bed up to 110 degrees. So I think it's going to work. It's got to work. Uh-oh, upside down again. There you go. Sorry, guys. So here's what we're going to do. Next step. Next step in the process. We have this thing. We have this thing. We need to find the M3x6 flathead cap screw. So here goes. We're going to find it. Did anyone see an M3x6 flathead cap screw around here? Okay, here's an M3x10. If we get the Dremel out, we can turn that into an M3x6. So I have a question in the chat. How many of you can tell what a screw is just by looking at it, just by eye? It's more like Randy Savage than... Well, who's Rand? Oh, Integrity Farms? No, I don't know who Randy Savage is. Here we go. I can tell that these are M3x6 flathead cap screws just by looking at them. Because that's my mechanical engineering chops at work. I've sorted so many of these things that I just know. Okay, so we need one of these. We're going to screw it in over here. For seemingly no reason. This just goes in like this. Yeah, sure, it's written on the bag, but I could tell the bag was face down. I can just see it. Okay. Yes, 9:30 seconds on your carburetor. Or three. Right. Okay, so we've got that. Now it's time for the next step. Thread locker, please. I don't even understand the purpose of this screw that I just put in here. Why is there a screw here? And why do I need to apply thread locker to it? I don't need thread locker. I'm just going to go out and say it. Okay, actually I'll get thread locker. You know what, on second thought, I won't get thread locker. And it has nothing to do with the fact that I can't find my thread locker right now. Mainly. Mostly nothing to do with it. Okay. Okay, no thread locker this time. I don't think I need it. Okay, next step. Okay, we got our extruder gears from Bondtech. Oh. There we go. Okay. Okay, so this is already put together. Oh, it's all like one piece machined. That's pretty cool. Normally this is two pieces that you assemble, but on this kit it's all integrated into one piece. Probably helps reduce the run out and make it print a little more accurately, so cool. That gets me to skip a step. Now we take this. I assume I put this... I think I skipped a step where I'm supposed to put a bearing in here, so I'll just go ahead and do that. This bearing goes in there. That press fit in nicely. And then yeah, this goes together like this with all the all this stuff sandwiched inside. So here goes. Got that. And then this goes here. That's pretty cool. That spins freely. Nice. Okay. Then I get two M3x25 socket head cap screws, which again, I have the amazing ability to tell what these are just by looking at them. If you want, I can scribble out all of the on the bags, so I can prove that I'm actually eyeballing these parts. Okay, so I need to find the fasteners. M3x5, 25. 3x60. This looks like an M3x30 if I had to eyeball this. Oh no, sorry, this is M3x25. Shoot. Oh, there it goes. It's written on the bag. Okay. Looks like our K2 is loading up the polycarbonate, and hopefully it'll start printing it soon. Here's the front row seats to the Voron building show. Okay, so according to the instructions, I put some bolts in, one right here and one down here. Yep. How much am I supposed to tighten these down? Is there a torque spec? Oh, tighten until the plastic bends and cracks. Back up 2 turns, discard parts, reprint or okay. So according to the instructions, I need to tighten these until the plastic bends and cracks. What the heck is that kind of instructions? Like, can you give me a torque spec? Initial alignment check. Mine should be aligned. I just trust that it'll be aligned. Okay. All right. Okay, the alignment in there looks good according to the instruction manual and according to me, more importantly. Okay, now I need those polycarbonate parts that are printing right now, so we'll skip ahead to the next part of the process. I think I'll skip ahead and we'll start doing the hello? Is the internet working? Okay, yeah, I can see my hand. All right, so now I'm gonna skip ahead to the next part. This manual isn't loading, so I have to wait. We got the little GitHub thing waiting. So I'll probably just download this and open it on here. So there we go, now we can see everything. All right, so I think I'm gonna skip ahead to that part. Oh, maybe not. That seems like a bad idea to skip ahead on that. I think I'll skip ahead so that I'm putting the hot end portion together. See this little one that looks like a little Metroid jellyfish thing. Oh, this one's got a little Sanjay face on there. Look at that. Look at that. I can pull that off. Let's go. No. It's not the same. Okay. So ERV. What? CW1, CW2, ERV. I'm not sure what that means. Okay. So we're just going to put the heat set inserts on this thing that we have here. Oh yeah, this one has the Sanjay head on it. Okay, so that's the right part. Alright. So we'll get one there. Here we go. Alright, so we're going to put 4 heat set inserts into that. One. 2. 3. 4. Okay, so this, I've been streaming for 75 minutes. That's more time than it took me to put together the Ender 5 Max here. Oh, sorry, upside down. That's more time than it took me to put together the Ender 5 Max from a kit. So you could either have this printer, or you could have this much extruder assembled. I don't know. Seems like an obvious choice to me, but some people like the unlimited to-do list of Voron building. One. 2. All right. 3. So this is for like a ADXL mount. I think that's an accelerometer. There's 2 optional heat set inserts in here. I'm not sure if that's included with this kit. I think the ADXL might actually be built onto this thing. Maybe. But we'll see. Alright, next step. We gotta get the Revo heatsink. Ah, okay. So they put the Sanjay face on here because this is the Revo compatible version. Makes sense. There's a little bit of stringing in here, so I'm going to take care of that. The best way I know how. Just need the other half of this thing. Oh, wait, hold on. I gotta restart. I gotta restart the print on the Creality. I must have made some kind of mistake. Sorry, guys. The Creality is. We're gonna give it another chance because I'm completely unbiased and I just. Oh wait, looks like it's working just fine. Look at that! Wow. Wow! Look at that quality Creality stuff. Yes. Now, a lot of you might not understand why I'm a Creality shill. And what it really comes down to is that I don't like Bambu Lab. So, of course, I just have to, you know, like everything that isn't a Bambu Lab printer. Unfortunately, there's a lot of options out there. You know, we've got all this great stuff. All this, then we have one of these down here. I actually do like designs, but I mean, the company's just kind of, you know, they're not the best in terms of the quality of their people, the character, the content of their hearts. Okay. Whoa. Who's saying no excuses? Erdu. Why the stealth burner? Bamboo Fund. Oh, Zombie, thank you. Zombie is so generous. Thanks to Zombie Hedgehog, I can afford to eat my lunch, which is a banana for scale. Okay, so we'll put this on there for the small price of $1.49. I will be able to eat a banana, so we'll leave that there. Okay, Voron building is for people who read manuals without skipping. Alright, so I don't know where the torch part of this is. Do you think I could just, like, get a screwdriver and push in there and then light it on fire? And then we could get that over there. And that might work. Might not be the best idea, though. So we'll find out. We'll get something a little more, I guess, safe. I do have a heat gun. Oh, wow. Hold on. I was wondering where this went. I wonder if this will work. I don't think it will, because it's a hairdryer. But I don't think it'll get hot enough to melt plastic, because it itself is plastic. And it might also break a circuit in here, since I have the printers running and everything, so... sometimes it's not so easy. We gotta find all the right tools for the job. We have our soldering iron up here. Oh, crap. Okay. So, was anyone expecting the Creality to work first try with an exotic material just like that? Boom. Beautiful parts. Hopefully they stay attached to the bed. All right. So, oh yes, Luke's Lab. Welcome, Luke. I know we all love the Voron design. So the reason why I want to get rid of the string in here is because it's a duct, and little bits of string inside of a duct are going to cause huge amounts of back pressure on the fan. Not a huge amount, but it's like a pretty good amount. Oh, did I? Oh, I called it the Voron Trident Voron 2.4 Rev D Kit. Okay, sorry about that. Okay. Yeah, I need to clean up my office, I think. In my professional opinion, I could do for a little bit of office cleaning. But I'm okay with there being a little stringing in here. Maybe I'll take it apart and fix it later, but for now we're just going to go for it. Okay, so we've got to put on the other half of this, which let's see if we can find it. Okay, I think I'm missing another part now that I think about it. So there's another part that goes on top of this, and it sandwiches everything in there. Is it this? No. I might have to fire up another print job on the K2 Plus. Okay, what is this part that I'm looking for called? It's the one that goes over the top of this. Okay. Yeah, I'm not finding it. I think it's going to be faster to just print a new one. So, figure out where to download that on the Voron Stealth Burner page. I'm going to go to STL's Stealth Burner. Print heads, Revo Voron. Yeah, so this piece, we're just going to go ahead and download this and then open that up in Creality Print. Alright, so the reason I'm having so many issues with these parts is I had someone print these for me because I didn't have access to any printers that could do ABS, because I don't like ABS and I got rid of all my ABS capable printers. So I had someone else print them, and they turned out, well, I don't know if I was asking for the right thing. I was like, hey, make me Voron parts. And then there's all these specific pieces that maybe, you know, he didn't know I needed or whatnot. And a couple of the parts ended up a little warped, so they cracked when I put them together. And, yeah. I didn't swipe anything from the lab, Luke's lab, other than four tube conductions for the big printer. Definitely swiped a couple of those. Okay, so we've got to print this out. I think Is this it? No. I can't find it. Yeah, we're just gonna print it out of polycarbonate. You have bins of stealth burner parts? Or bins of, let's see, or bins of tube conductions. Because the tube conductions make sense. Delete. Okay, I'm going to slice this plate and we'll do that one as well. Alright, so I'm going to check in with the chat. See what you guys are up to. I don't think you gave me any printed parts for this. Oh, it does specify the infill percentage. That's a good point. It's supposed to be like 4 perimeters and like 30% infill or something. I'll fix that. And maybe I should reprint the other pieces too. So we're going to set this up. We'll change the settings. So 4 things and I think 30% infill. Is that the Voron standard? Voron print settings. It says 40% infill, any infill pattern that you want, and 4 loops. And 5 top and bottom layers. That is for ABS, and I think polycarbonate is a little bit stronger, but we're just gonna reprint everything so that it's nice and beefy and won't break. Okay. Export plate. Okay, so I've export those new tray of parts with more infill. We'll just go ahead and run that print job. Now, the K2 Plus has a great offline workflow because plug the flash drive, but the printer's still working. So I can just plug it in with the new stuff in there. We'll stop this print job. Stop. Oh jeez, what the heck was that? That was that was it dumping. Okay, anyways. Flash drives are the best. I don't know what you're talking about, Luke's Lab. You take that back. Yes. Some parts go 100% infill where you need strength, mostly for the belt idlers. Okay, thank you for the 350 ZAR, whatever that that currency is. I'm assuming that's like $1 billion, a bajillion. All right, we're gonna print out our stealth burner parts. There we go. So it copies the files over, and then I can immediately unplug the flash drive. Ta-da! Great stuff. Okay. So here's our our polycarbonate parts off the K2. What do you guys think? Is it good? Is it bad? It's awful, according to Luke. No further explanation needed. This is Bambu Lab polycarbonate. I think it looks good. This is pretty nice quality. Ah. This is a strong part too. These are like pretty strong. Polycarbonate is some good stuff. Yeah, I'm doing 40%, so more than twice as much infill, and also 4 perimeters. So these should be a lot stronger in the next batch. Here's some more pieces. Cool. All right, so an hour and 45 minutes later, we're going to have our parts that we need. But in the meantime, I need something to work on. So let's page through the instructions manual and see what else we can get up to. Also, I'm having trouble getting the print profiles to be able to run this thing. I was actually having a conversation with Luke's lab earlier about start and end G-code for printers and how it's a total mess in the current state of the 3D printer market. So I'm going to figure this stuff out. I'm going to make a video about it, complaining about how we need standardization in the way that we write G-code, because the point of G-code is so that you have a standardized way to tell machines what to do. But when you have every machine have a different procedure for starting up, where it's like assign the temperature, do all this stuff, then it just kind of it doesn't really become as universal as it should be. So these two machines are 400 by 400. I would really like it if I could send the same G-code to this machine and that machine and have it work. But as it stands, it's not like that. Everything has their own like stupid chunk of G-code at the front that is totally machine dependent, so it should be wrapped up in a macro, but instead it's, So I'm going to do a little lecture on interoperability and how that's important. Yeah. When I buy cam software, I pay the extra per machine I want to run with the cam for the post processor. Not sure what all that means, but I'm sure it's important in machine design stuff. Okay, I'm gonna eat a banana thanks to Zombie's generous donation, and I'm going to go one step further and eat an orange. We're gonna treat ourselves today for Benny Collar Venter's donation. So we're gonna eat. We've earned the right to eat today. We'll stream for food. Okay, what else do we want to see? I was supposed to have received a profile of basically so I can start running this machine, but I'm not sure how to use it, what I've been given. Hold on, let me plug in my computer. So this Uri1 Thinker has been doubling as a desk. So you can see I've got some extra real estate here. All these other printers take up room on my desk. This one is the only one that adds desk space to my office. So I really like that, this here Thinker. Okay, so this is what I got from Anycubic, or from Everyone. They sent me a Orca Slicer thing, like a file with all the Orca Slicer stuff. And I guess I'm supposed to put that onto my machine. I think I didn't copy something over that I needed to copy over. One of these JSONs. So I'll need to copy this JSON over. And by the way, you might think this is controversial, but I do sponsored videos for these type of machines that are still in development because they take a lot more time for me to like get running and working. So this is basically paying for my time of like the extra troubleshooting they have to do on these pre-production beta test type units. I'm at the point in my YouTube career where I can't be doing free beta testing for all these companies. So yeah, this one is coming with a little sponsorship. We're going to do a video going over all the features. But that sponsorship helps cover, you know, all my operating costs and the extra time that I put into working with a machine like this and providing feedback to the manufacturer. Okay, so we're going to copy that. And go to Applications. Go to my, where is that? Orca Slicer. Show package contents. For those of you who aren't in the Mac world, this is how you do things. Profiles. All right, we'll paste this JSON into here. All right, and then go ahead and close this and reopen it. So, what do you think? New project. Add remove printer. Let's see if the furry one is showing up. It's still not showing up. But yeah, this thing has kind of triggered a rant in me. So I'm going to be ranting about how we need to standardize our G-code amongst all of these Klipper machines. Ah, here we go. Thinker X400. We got that. All right. I'm going to start up a print job on this thing as well while we're at it. Someone told me I need to print a Mandalorian helmet, which I think is silly, but we'll give it a try. I've run a couple prints on this so far, and it seems to be working really well, except for one thing, and that is the first layer Z offset. I need to get that dialed in a little bit. I'm not sure. It probably has to do with the startup G-code not producing a bed mesh unless you're using the specific thing here. Let me just go into the specifics of that so you know what I'm talking about. So if we go, this is the best way to screen share. You just hold up to this here, and then if we go here, we're at the thinker. If we go to right here, you can modify and then look at machine G-code. Look at all this startup G-code. What I would like to see is all of this wrapped into a print start macro. So they run print start here, which is a macro that has like a certain procedure that it runs to start up. That's like your nozzle purging, making sure everything's up to temperature and homed. But in this one, it doesn't have that stuff as part of the print start macro. Instead, it encapsulates a bunch of that code in this machine start G code area. But what I'd like to see is all of this wrapped up into into the print start command, so that all this says at the beginning is print start, heat these two things up to this temperature, and then go. But, you know, I basically couldn't use this machine without this specific profile with this specific machine start G code, which I think is kind of silly that we're at that state in all these Klipper machines where everything needs a specific slicer in order to work. But anyways, I digress. Let's set this up so that it's got two walls. We'll turn on support material, tree support, tree strong, and we'll slice the plate. And slicing a print job like this usually takes a little while because, you know, reasons. Maybe I want to increase the number of layers here because this Mandalorian helmet looks like it's designed to break open. You can see this this line from here to here. That's going to be one layer, and that's going to be super easy to snap if you're wearing this like a helmet. And that's like, it's not a great orientation to be printing this in, so let me cancel that. So what I'm going to do here is tilt this back a little bit. That should help it get a little closer to the bed as well. And actually, yeah, tipping it back a little bit is going to help make it a little stronger and bring it closer to the bed, so less support material will be needed. And then I'm also going to increase the number of wall loops, maybe 3. That'll be a little bit stronger. Okay, and we're printing PETG, slicing up this plate, and it'll take a minute. All right, let's get caught up with the chat. Hold on, where is... I had a window with this open. There we go. Okay. Yes, maybe use standardized libraries and functions. I have a whole... I'm going to do a whole whiteboard lecture / rant about it. I think, you know, if you draw out a diagram of all the parts of the printing process, you have the slicer over here, you have the printer over here, and you want them to be able to talk to each other, regardless of if you're dealing with slicer A, B, or C, or printer, you know, X, Y, and Z. You want every combination of those to work out with the same communication language or G-code between those machines. So I'd really like to see a situation where every printer can translate between this 400 by 400 printer, that 400 by 400 printer, or if I can take my file from a Bambu Lab 256 by 256 printer, I can just chuck that G-code onto any printer that's larger than it, and it should be able to handle it. But I'm not sure. Not sure it'll be able to deal with that. And some, like, I guess, regulatory body should get involved and try writing a standard. I know that standards are really common in a lot of electronics industries, like especially computing hardware. However, I'm not sure exactly how that will work with China manufacturing most of these things. Seems like China as a country doesn't like to standardize things, just because that requires other companies to pay into like a consortium where you hire an independent body or hire one of the companies, one of the big players, to develop the standard, because that takes a lot of work, and then it's like kind of a document you can share between all the other entities, then everyone can get on board with the standard, like PCI Express or HDMI or Thunderbolt standards. Then you have to like license them and pay another person to get access or approval to use that stuff. But what often happens in China, I assume, is that they just use those technologies without a license. So Standard is usually certain industry to make more money. It ends up being easier on the customer in some ways, but also isolate them. Yeah. Standards are a good thing if you ask me. Like computer hardware, imagine being able to put a printer together like you put a computer together. You just buy a bunch of parts and plug them in and they automatically work. Okay, so yeah, that should have finished slicing by now. Oh no, it's still slicing. With these really large prints, oftentimes they take longer to slice, especially when you got tree supports and stuff in there. This is an interesting supports. What the heck? Wow. I've never used the strong tree preset. It's pretty interesting. The tree supports have their own infill, so that should make it quite a bit stronger. But there's also like, we'll see how that works. I'm a little skeptical, but let's go for it. I trust Orca Slicer. Okay, so let's export that G-code. Okay. There we go. Also, I'm waiting on, speaking of G-code compatibility, I'm waiting on a profile from Creality to be able to print with the under 5 Max. Because I can't run, I didn't bother trying to print anything other than like the default prints that they came pre-sliced on the printer. But just because usually I'll do a first review that's like that. Just basically unboxing it and doing what's included on the SD card. And then I'll do something a little more detailed where I slice my own stuff. And I wanted to get started on that video where I was slicing my own stuff for this, but I don't have the specific startup G-code that I need. So this interoperability thing is something that I'm becoming more and more annoyed with because I have to deal with it on all of these beta test, like early adopter type machines that I get. And it should be a lot easier for regular customers because by the time you guys get it, the slicers have all been updated and everything's working fine. But these are just early access YouTuber first world problems. Okay, so let's export this. I'm running this offline too. I'm going to set up a little wireless network here so I can have like an offline local area network to do all this stuff. New elements. But for now, we're just using USB cards, and I feel like USB sticks is the best way to go if you've just got a few printers on in your office. Alright, we'll plug it in. They have a different issue where they absolutely suck at supporting my printer features. Oh, are you talking about Klipper? This sounds like a Klipper problem. Alright, new helmet. We'll print that one. And go. So this is actually the first print that I've ever attempted on the Thinker 400X, X400. This thing's a beast. It's like really big. Look how fast the heater heats up. So the hot end heats up super fast. And I'm just going to be printing with PETG for this one. I like PETG. It's going to be white. I guess that would be easy enough to paint if I wanted to paint it. I don't know what paints you use on PETG, but... oh, the camera's mirrored. Oh no, that means you can't read anything. All right, hold on. I think I have a solution for that. I just need to get a mirror, and then, you know, everything will be reversed. Oh, the G-code rant? Okay, well, I mean, regardless, the G-code is gibberish either way. It's all nonsense that shouldn't be there. So, good enough. Alright, so this thing should be printing. This thing's printing away. It's doing our new polycarbonate parts. What else is there to do? Now, what's funny about this Uri1 Thinker is how much it copies from Voron. You can see the cable chain management is almost identical. The print head is a little silly. It uses a massively oversized bed, so it's like super thick. But it's got some of its own features that are pretty cool, like it's got a force sensor in the print head, so it can do that kind of probing to hopefully get you a good first layer. I'm going to check what the chatters are up to, what the kids in the chat are saying. Voron loading. Oh yeah, you're in the Voron right now. Here, let me move you back a little bit. There you go. There's the Voron. Alright, is that better? Now you can see the Voron. That is a weird looking positron. Nomads, I don't have a positron. You know this. Alright, 3D printing community wouldn't exist if standards weren't always being pushed. I put my Ender 3 on Klipper, upgraded the print head extruder, now can push it to 180 millimeters a second. Need to add input shaping to go even faster. Yeah, pushing cheap printers is pretty fun. Okay. Wow. Wow. Okay, so according to Luke's lab, it's even worse with industrial CNC machinery when you have to get like machine-specific G-code, because I guess that's just another thing for everyone to sell you. It's like, here's our machine, now you need to buy this software so that you can actually use it. G-code post-processor, woo! I have some G-code post-processors that I wrote for my quadrupolar machine, and I was actually thinking, it's like, that's actually, I mean, it'd probably be legal to have that at post-processor that you write yourself that you can't use the machine without. And then the question is, do you give that away for free or do you sell it? And I mean, technically you could sell it as an add-on to an open source slicer. So there's ways around the whole idea of open source. Okay. So enough about macros. I'll make a whole video about that topic, and we'll see if anyone finds it interesting. It's kind of a boring topic, but I do think it's important that we kind of make things more standardized instead of less standardized, because it bothers me that I have to have machine-specific slicer settings just to do anything with these machines. Okay, so I guess I can start putting this part together. We'll skip ahead in the instructions. And I guess this probably has a couple of fans stuck into it. It's got the LEDs. I got these LEDs I gotta embed in here somehow. Okay, so looks like this goes here. I'm a little worried about this. Oh no, I feel like I'm gonna break these little SMTs. Looks like it's fine. Okay. Okay, there's a diffuser that's supposedly printed in a different color. Okay, well, I don't know where that is. LED wire routing. Okay. These completely necessary RGB lights must be inserted in a specific way for a 10% speed boost. Okay, got that. We got one more light. That one needs a diffuser. Well, we're not going to put a diffuser in here. We're just going to have a blinding LED light pointing at your face. Although, I'm pretty sure I did see that diffuser at some point, so I'll look for it for just a minute. Let's see what we got. Excuse me. Okay. All right. And I've got more parts here. Whoa! I've got more parts. Maybe the part. Oh, here's the part that I needed. There it is. Okay. Well, crap. Huh. Okay. Yeah. No. I have all those parts. I'm printing them out in polycarbonate right now, but I guess those will just be spares. Because it looks like I'm finding the pieces that I needed. Which means the build can go on. I just had another mystery box of parts. Here. Ah. Here's the little diffuser. Off topic. On topic of G-code compatibility. Just went to Orca Slicer, added generic Klipper printer, chose nozzle size filament, and then, hold on, sliced the part, heated my tool head, and hit print on the Q1 Pro. Well, all right. Well, that's pretty cool. I guess if Cheaty is doing it properly, where they have their G-code set up to just eat whatever's thrown at it, then good on them. I like that. I think with this Ender 5 Max and the X400, they have to catch up a little bit on that front. But part of the issue might be that these are pre-production, and they haven't like ironed out exactly what the startup, like the best startup G-code should be. So maybe they're still editing it and modifying it, and they find that it's easier to just do that in G-code. So who knows? But in any case, they should definitely push towards having a standard kind of print macro setup at the beginning of every print. Okay, so here's our little diffuser. It's printed in a transparent PETG. This isn't very clear, but I guess it is a diffuser, so it will diffuse things. So I have all these parts out of ASA, I think, and I can move on with the build. If any of these parts ever break, at least I'll have my spares that I'm printing right now on the Creality. So, hooray, that means we can continue. Alright, let's do it. So, resume overhead cam mode. Oh wait, and let me make sure, yeah, we've got plenty of battery life. We're good to go. So, this gets installed here, like that. And then we need 4 screws to attach these 2 pieces together. Alright, and here's an issue. This says canceled. So this is with the G-code that they recommended. So, you know, This is the kind of BS that I deal with these printers. We'll go ahead and try to print it again and see what happened. If we go to settings, look at the console. Let's see. The machine thinks it's 420 right now, so at this time it said bed mesh has been saved. Extrude below minimum temp. So apparently in this startup G-code, they never set the extruder to the right temperature before it tells it to extrude. So then it throws an error, and then, you know, things aren't working. Yeah, man, dealing with pre-production machines are fun. Okay, what machines are y'all printing your life away with? Good question. What is everyone printing with at home? We need a survey. Survey to the audience. All right. So I need 2 M3x16 socket head cap screws. Alright. 3x16. 2 of these. I'll get you up here. This is the least exciting camera angle because sometimes I get distracted and go somewhere else. Then you can't see anything. But we're going for it. Okay. Bada boom. And then M3 mounting bolts, M3x8s. Okay, that part's done. I'm gonna put my little diffuser in here. I'm guessing there's a little piece to like hold this onto the diffuser. Whatever I'm looking for, I can't find it right now, so. Alright, PTFE tube. Alright, PTFE tube time. I assume they have a piece that's cut to length already, but I can't find it, so I'm just going to cut my own piece to length. says PTFE tube should stick out 11 millimeters above the surface of the printed part. Okay. Oops. Okay. Get something to cut that. Okay, LDO provided me with this this ruler, which I can't use since it doesn't go all the way to the edge with the measurement. So I have to eyeball what 11 millimeters looks like. Probably about like this. There we go. Okay. All done. I have a feeling this is the wrong type of PTFE tube though. This has too large of an inside diameter to fully constrain the filament. But we're just going to go with it. If it causes an issue, I'll just take the thing apart and fix it. Like when I put the filament in here, yeah, that's got tons of extra space. Not sure if that's a good thing. It's like wobbling around in there. Okay. I need some of that sweet Capricorn tubing. And this kit probably came with a pre-cut piece of PTFE tube, just with how well presented everything has been so far. And oh, here we go. We've got some PTFE tube right here. Let's pull this whole piece out. Assuming this was cut to the right length, we'll cut that to the same length. Okay, and I'm just using this tool to kind of straighten this out and make sure it's open. And this should actually help flare it a little bit. If I had a razor blade, I'd clean this up a little bit more, but I think it'll be fine. All right. Right now it's about 13 millimeters, so I've got to cut off a little bit. Alright, I'm gonna check back in with chat and see what you all are printing your lives away with. Looks like this view here looks like the same kind of mess wherever I try to accomplish everything. How's the build going? It's not going great. I'm not gonna lie about that. It's just going alright, I guess. 3mm ID PTV tube is great for the guide tube before the extruder. Yeah, I think that's what I got mixed up there. So JL Stis Pro has a Cheaty X-Max 3, a Q1 Pro, and two E3 Ender 3 direct drive and E3 Biku H2. Just tuned up the old K1 to give to the nephew, and then there's the resin printers for laser cutting and a laser cutter for acrylic. Nice collection there. Actually sold a CR10S Pro when you got the XM3, X-Max 3. Yeah, that's a pretty good printer. K1 Cobra 3 combo. Oh yeah, Cobra 3. I should check that one out. I think they offered to send me one, but it's like, do I really want another? I mean, the last thing I looked at from Anycubic wasn't very impressive. It was the Anycubic Cobra 2 and the Cobra 2 Max. Both of them had like below average build quality, and I was like, if you're going to get something like this, it's probably better to just get whatever Creality's selling. But now that they have the Cobra 3, I think they really upped their game a little bit. Apparently they're funded by the same venture capital firm that's behind Bambu Lab. So they're like kind of the unwanted stepchild of Bambu Lab, I guess, in a way. But their technology seems to have gotten some sort of infusion of higher quality. So I'd be willing to check out a Cobra 3 at this point. I would just, what I saw with the Cobra 2 wasn't giving me a lot of confidence that it would be any good. Are you building a hot end? Yes, I am. Are you building? Yeah. On topic of G code, I just went. Oh yeah, right. Production in the any grease. See, look, this just stopped printing because of some error. I was able to run the original test code on this that was loaded on the machine. So I think there's something in the startup G code that is not present in the way that I need it to be. So let's look at the startup G code, and then I have to apply my supreme knowledge of 3D printers to figure out what the heck's going on here. Then I have to troubleshoot. Now, Uncle Jesse did a video on this machine, and I'm not sure what he had different. So let me just flip this around. Maybe I need to update the firmware on this machine, because maybe the new firmware has a different start print macro, but they didn't tell me anything about updating the firmware. So maybe I'll just do that. I'll ask them to send me a new firmware to check out. Maybe that's what's going on. But it's saying that at a certain point, see, it's supposed to be heating. What? M117? Shouldn't there be like a colon there? A semicolon? Like, right, this is what it was. Shouldn't there be a semicolon there to note that that's a comment? If you look at console, it says probe med mesh leveling is completed. I guess it doesn't need that. Well, It looks like it's crashing some point after this, where it's done with the bed mesh leveling, and then and when it's supposed to actually start the print. So that's what we're dealing with there. Because the extrude below minimum temp, so it's probably supposed to switch at that point to a higher temperature. Mike Jones, you need to accept Creality into the gang of brands that have upped their game. Look at that. We're just casually printing some polycarbonate. Everyone is new to the game, possibly late to the game, and this printer is not great. Well, like, I can't get it to print, which is an issue, wouldn't you say? There's some issue with the startup G-code in this file, and I could open up the files and check out the startup G-code and figure out what's going on there, but it's just kind of annoying to have to do all of that. Okay, well, let's get back to the Voron, the project of the day. I just finished assembling this little block down here. Now I'm going to move on to the next task. Okay, so next step, we're going to put together the this little fan shroud thing. So there's a diffuser and diffuser mask. It gets slotted into this. What in the hell? Okay. So I can't find the parts for the diffuser mask to set up that third LED light inside of the hot end, which is lovely. Let's get this. Let's figure out what to do with these things now. I think I need to press fit some inserts into these. Okay, let's do it. Yes, blinding LED time. Alright, so it looks like I just don't have the housing. It's probably on the floor somewhere. Ugh. Yeah. I'm a little worried that the blinding LED will melt the plastic that it's pushed up against, because it's just going to be blasting it with the full output of the LED, which is probably like a watt or something. What in the world? Alright, time to shove these wires down where they need to go. Okay, so I'm a little confused here. Like, I'm supposed to get the wire to go through here, but it's attached to LEDs. So do I break that? Looks like I have to break that. Break those little supports so that I can tuck the wire in behind this. There we go. Okay, we got that light in there. Then I guess this cable comes back around here and gets plugged into some little area. So yeah, it turns out there are a bunch of little breakable support things to get things to print properly. You can just break those. Okay. All right. Okay. Okay. What am I doing next? All right. So that is in place. Time to look at instructions. Okay. LED wire routing seems okay. Support structure. Time to put a fan in. Alright, so fan goes in here. kind of goes in here like this. And then goes out up to the side. Now personally, I don't think that makes sense to me. I'm going to rotate it like this so I get a little extra cable length. And the cable is going to go out in the same direction that it says in the instructions. Probably the most valuable thing about doing a pre-built doing a home-built kit like this is you learn a lot of tricks that the designers of these 3D printed parts use to reduce fastener count and just have like functional 3D printed features built into your parts. Because that part is really quite valuable in terms of getting some design inspiration. Okay, part cooling fan. Remove the front of the fan? Are you kidding me? I don't want to do that. Why don't I just put this in like this? Right? Wow. What the heck? Remove the clip off the side mounting ears? What the? I don't want to do that, but if that's what they're telling me to do, I guess I do it. No turning back now. Time to clip off those ears. Oh God, this is a bad... Why? So this needs to get like jammed in here, and it can't fit unless you cut these ears off. What are they smoking over at Voron Design? Oh my gosh, I just broke this thing. How am I supposed to clip these ears off? Alright, here goes. I think this is probably the right tool for the job. Or maybe a lighter touch is required. Maybe I'll just do this by hand with one of these. They say clip these off like it should be easy to clip off some frickin' solid. Like they should tell you to Dremel them off or saw them off with a small, clip them off. They don't just get clipped off easily. That's ugly. Don't like that at all. Alright, I probably should have checked with the chat before I just went full speed ahead with this plan of mine to just start sawing things apart. But I think I'm reading the instructions correctly, and it says to clip those off, which is pretty wild to me. Okay, time to look at the chat and see how dumb they think I am right now. Hacksaw blades work well for stuff like this. Those metal saws took forever. I think you're better off cutting off the plastic than sawing, but I've cut wood with a saw like that, so I won't laugh. Well, this is fiberglass reinforced nylon. It's like a relatively stiff material and fragile, like it tends to crack, not snip off, as they say. So then this just like fits in here, I assume. Once you've done enough damage. Jeez. Okay, this is pretty cool, but it's pretty hacky. Like, I'm okay with this being a tiny bit bigger if I get to just integrate and insert the whole fan. Oh man, this is already broken too. Look, I've got delamination here. Right there. Oh well. Okay, so that's good. All things relative. That's okay. Pretty good, I guess. Oh, did I cut the cable? Do you think I would cut the cable? Come on, I know better than that. I've cut the cables on like a dozen Ender 3s before this, so I learned that lesson already. Okay, let's get back to the stealth burner. Alright, time to flip the camera around a little bit. Up here, it looks like this goes in like this. Like that. That looks like it's about right. And we need the M3 by 30 socket head cap screws there. You know what? You guys are getting put over here for now. You're in timeout. Alright? You've had enough. Good views. Good close-up views. All you did was make fun of how I did things. So now you don't get to see at all what's going on. Okay. Time for those M3 by 30s. Ta-da! Two of these. One there, one there. Just making sure those are socket head cap screws, yes. And I need a little plate behind it. Oh my gosh. Okay, so that everyone isn't wanting to start the print job. Because the extruder is too cold after it finishes the bed leveling to to like actually start the print and start extruding for whatever next step there is. So I'm going to try to like issue the command to set the print head to 220 degrees a couple of times while it's getting started. Alright, and time to finish the extruder before I move on too far. There's a little piece that I need to find or print. It's basically a plate with a tiny little square with two heat set inserts into it. And I can't find it, so that might be another piece I have to print out. I'm gonna jam this diffuser into this. Oh no. Okay, well, one of the LED lights, the little solder joint failed, so I'm just gonna pull the LEDs out. Okay, I can solder it. But think about if these LED solder joints were to break while the thing's assembled, it would cause a little short circuit and fry some things. It's not good. So why are we bending and jamming these lights into this little corner in a very undesirable way? Come on. I don't understand why nobody complains about the Voron designs. Everybody complains about Creality and Bambu Lab and Prusa all day, but nobody ever complains about Vorons. Okay, my soldering iron is not hot enough to do this. I think I need to change the batteries. And I have a other hot soldering iron, but honestly I really don't care about the lights. So I'm just going to pull them out. It's just more crap that's unnecessary. I just broke another light cable, so we're done with that. You know what you need on a hot end? Fans. Fans and heating elements. So that's what we're going to go with. Okay. Alright. Side quest canceled. LED side quest is over. We're moving on. Alright, M3x6 flathead camp screws. We need a couple of those again. One, two. Alright, and the other thing I'm going to do is I'm going to log in. I'm going to open up this Wi-Fi router, get it set up so that I can log into this thing, the Thinker X400, and do some Klipper config messing around just so I can get it printing. I like these little travel routers because they weigh basically nothing. They're tiny little things. Oh, look at the little cute antennae. And I think this has an Ethernet port. Let's get this all set up. It just runs off of a USB-C cable, so even if I wanted to take this out and just run it using my power bank here, I could do that. But I'll just plug it in because I'm going to use this for all my printers. And then next time this print fails to initiate, I'm going to log into it over the Wi-Fi and change the printer.cfg so that it will lower the extrude temperature, and it'll be fine with running the extruder at a lower temperature. Worst case, it'll cause the extruder to skip a couple of times before it actually gets started. I'm really not worried about that because it's at 150C. It'll, try to extrude and it'll be like, and it won't do anything. And then it'll assign the temperature when the print actually starts, and then it'll start printing just fine. So that's the idea, that's the plan for now. We'll see if that works out. The only downside is my computer has to be switched to this offline network whenever I want to mess around with my computers. That's just a side effect of wanting to not put the printers on the actual internet, and I'm fine with that. Okay, so what next? What next? I need to print out the little Omron switch holder to check what the chat is up to. 59 of you right now, so a nice amount of people. Very nice. If we were to make a print farm for smaller objects, I'd consider one of Rolohan's projects, but there are a ton of ready-made cheap and good options now. Yeah, print farm for small objects. I would use the Ender 5 Max, personally, because then you can load up like 500 of them and run it overnight, and then just like wipe them all off the plate. If you want to spend less money, then you could do something like the Bambu Lab A1 Mini. You could get like 1, 2, 3, 4. You can get 3.5 A1 Minis for the price of one of these, but this has like 8 times the build area, so it's really up to you whether you want to deal with a bunch of small machines or a few large machines. And that really has to do with how long you want the print jobs to be. Ender 5 Max can be set up to IDEX. I guess the other thing with the A1 Minis is that you would have faster production rates because, you know, 4 slightly slower printers is going to be faster than 1 faster printer. But I just think the convenience of having gigantic trays of parts would be pretty nice if I was actually... And this thing also has like a little tally lamp, so it tells you when you need to check on the machine. Because for me, I think if I was running a print farm, I wouldn't want to have as much operations to do. I'd want to be dealing with as few things as possible. So as few printers as possible and as few print jobs. So yeah, that's my thoughts there. Plus you could scale these to print large objects instead of, you know, being forced to print smaller objects. Alright, Ender 5 Max, can it be set up to IDEX? No. If you want an IDEX large format printer like this, I would check out probably RatRig is the only people that are offering something like that right now at like a consumer price point. The DIY machine is truly needing more maintenance than the A1 Mini. Yeah. Yeah, and honestly, you'd just throw the A1 Mini in the trash as soon as it has any problems and buy a new one. The nice thing about small printers like that. Okay, let's see, what are we doing here? Yeah, I like VZ bots. I'd be interested in building one because it seems like there's more of an emphasis on performance. Having aluminum machined parts makes a lot more sense for a machine that you want to go fast instead of like as much 3D printed parts as possible. 3D printed parts are fun and all, but at the end of the day, these kits end up costing so much that you might as well be going for high performance and, you know, paying for aluminum parts with how much you're paying already. But really, the Voron project is more of a fun thing for DIYs and community engagement. Like, you get to go to the Rep Rap festivals, bring your Voron, show it off. Everyone's like, "Whoa, it's so cool! Did you print the things?" And you're like, "Yeah, I printed the things, and now I can print more things with the things I printed." And yeah, so it's definitely like a community type thing. There's more value to it than the actual machine itself, because if you're looking at this machine and comparing it to what else is on the market, it really doesn't make sense for a price to performance perspective. Okay, so we got that, those 2 screws in place. Now let's go back to the extruder and deal with that. So, yep. Oh my gosh, this looks complicated. No. Why? Okay. Alright. I need this little guy, but in a different form. There's 2 different versions of this because Voron decides to support basically every configuration of random cable chains and whatnot. I think this is the piece I need. So we're going to have to put 3 heat set inserts in here. The other thing is the amount of time that it's taking me to coordinate, figure out all the parts that I need to print and build this, and actually run the prints and everything. I could literally set up an entire print farm in the amount of time that it takes me to build this one machine. Because these Ender 5s take like an hour to build each. Something like the K2 Plus or anything from Bambu Lab is going to take you probably about 20 to 30 minutes to set up and get started with. So like, if you're thinking about setting up 20 printers, that'd take you 10 hours with stuff like this. Or 20 printers would take you maybe 2 days for stuff like this. For Vorons, you're gonna set up like half a printer in 20 hours. So it's just the endless to-do list of things. All the things to do. You'll have them all. Alright, let's do this. Heat set insert time. Wait for this to heat up. Oh, I need to start drinking coffee. I have in my possession 8 shots of espresso in my water. Just look at that. This is the pure essence of coffee. Delicious. Take a look. Doesn't that look like a good time? Yeah. I think it can make sense to do a print farm. Like, I think there's ways to... Hold on. Let me make sure you're right side up. I think there's ways to do a print farm that makes sense. Wait, hold on. We gotta get the ambience. Oh, jeez! Okay, I just stabbed my arm with the soldering iron on accident. We're okay, though. Okay, let's get you set up over here. Okay, anyways, I do think it can make sense to do a print farm. If you've got a business plan and you have a reason for it, then you know how you're going to make a profit. If you don't have any of those things, then you don't need a print farm, and you definitely shouldn't buy more than like 1 or 2 printers. Like, I think if you actually want to do a print farm, the hard part is finding customers and sales channels. The easy part is getting the printers and setting them up and running. Because especially if you enjoy 3D printers, like, I think that's a lot of people's dream, to be able to just go to place an order for, oh jeez, these are hot. Go place an order for like 20 3D printers and get a gigantic care package from Shenzhen with all of your favorite goodies in there. Okay, there you go. Oh, we've got more to do. There we go. Alright, so I need to name my printer. Isn't that a thing where you need to name your Voron? I mean, a lot of people name their other printers, but I feel like if you're not actually building it yourself... Oh crap, maybe I needed to put heat set inserts in this one. Well, I'll do this one as well. Hold on, I got extra parts to put in here. But I feel like with the amount of time invested into a Voron, now you get to make one and it's all yours and it's special. It's your unique little printer. There's many like it, but this one's mine. I think it's okay to name it, right? It's only a little weird. Wait, this one has... This is the same part. Okay. I'm just gonna do them both, whatever. Hopefully I have extra of these heat set inserts. For most people, I don't think 3D printing is like a hobby that results in something massively productive. It's more about the friends you make along the way, right? Like, you know, get a 3D printer, do some stuff with your kids or your family or your friends, or, you know, go to a convention and meet new people that are also interested in 3D printing. So don't get too bogged down in the practical aspects of 3D printing. Just think about like what it's going to do for you and your social life and, I don't know, your feelings of freedom and your ability to make random things. That's probably more important. And our Area 1 thinker is printing away. My genius move of repeatedly telling it to be 220 degrees worked. And now it decided to print, start the print. I think this actually needs to be hotter, though. So I will turn this up to 240. And that might have already caused some issues. You can see that this on the side has got a little bit of bad print quality. That's probably from it not being hot enough. Since I'm printing with PETG, usually you want it a little more than 220 for the first layer. So I'm gonna actually hit cancel, and I don't want to cancel, I'll just hit exclude object, and I'll click the right ear and hit continue. So now it just deleted that little piece off, and that was the one that had the slight issues with the first layer quality. So that's one of the cool features that they integrated onto this machine, so that if you're messing things up, you can kind of fix it a little bit. Okay, anyways, back to the heat set inserting. Andrew is a Hungarian. Why are we calling out Andrew for being Hungarian? Yes. I got a scar from the... I think I'll be fine. Anyways, where were we? Putting in heat set inserts. We put them in these. Put one in here. And then I need to put one in this little... Where is it? There it is. It's on the floor. Okay, this little thing, I think, is what I was looking for. Yeah. Okay. And looks like I take this piece. There's another piece that kind of looks like this. There's too many pieces in this printer. I tell ya. They really need to get the part count down. It's absurd. Okay, so this goes here. Okay. Then we need our little... I think I stuffed 2 of these little bearings inside of this little gear. And then I put the steel shaft. It's, yeah, over here. Through that. And then put that in there. Okay, now it's just a simple matter of forcing this in because it doesn't fit. All right, just like that. There we go. Then we get the other side. I think this is the other piece. Nope, nope, just like this. Yes. Okay. And I don't have a hammer, but I have this large cog on the ground. Okay. That's all put together. And I guess I need to screw this together, though it feels like it's already one piece. Need a M3 by 16. M3 by 12. No, we need no, not M3 by 8. We need specifically an M3 by 16, not an M3 by 6, not an M5 by 6. No, where is it? There it is. Okay. All right. If you saw that and you were trying to tell me in the chat, you're the real MVP. All right. Here we go. Oh no. Oh no. The Creality. Ah, dang it. Alright, whoever bet that the Creality was not gonna be able to print the polycarbonate parts the first try, you're wrong. Ha ha ha. Pay up, suckers. That's right, Creality's the best. That's right. Ha ha ha. Alright. These are some pretty amazing looking parts. And they worked first try. Wow. Wow. I feel sorry for anyone who bought a Bambu Lab X1C, because just look at these beautiful parts that I'm getting off of my Creality K2 Plus. Ah, yes, that's amazing. Look at this. I'm sorry, does the X1C have a chamber heater? I know it has an MSRP of like $1,200. Does it have a chamber heater? No, it doesn't. Oh, does it have a 350 by 350 build area? I don't think so. That's really unfortunate. It's only 256 by 256. Why not nylon instead of polycarbonate or ABS? Nylon is very flexible. The only way that I would want to use nylon for, like, nylon is pretty similar to TPU in terms of how flexible it is. So if you want to make parts out of nylon, Really, you want to use nylon reinforced with carbon fiber or glass. PA66? I don't know. All I know is nylon is not very stiff compared to most plastics. And you know what they use polycarbonate for? Bulletproof glass. Therefore, just using basic logic, polycarbonate is stronger than bullets. Right? Okay, so that M3x16 is done. Next, make sure this is lined up correctly. I assume it is. Alright, time to put the little spring latch thing. So I've got like a special custom machined thumb screw. Because, you know, what kind of good open source project is that's designed to be sourced from random components wouldn't be complete with a very specific thumb screw assembly? Oh yeah, if he used polycarbonate windows for the Cybertruck, it would have at least been able to stop a ball being thrown at it. Definitely. Alright, so this is all good. Yes. All good there. Now I put the bearing in place, yada yada, blah blah blah. Next, I need to put this into the this thingy. So this goes in over here. How does this go in? Like this? Da-da-da. That's pretty cool. All right, now that this is all coming together, I'm a bigger fan of this project in general. It is binding a little bit when I put it in there, so maybe I need to loosen this screw a tiny bit. I'm not sure how this all is supposed to work. Yeah, it is definitely binding when I insert it all the way. That's not good. Well, anyways, let's put the M3x25 screw in and see if there's any fine tuning we can do. Ideally, an assembly like this, oh, you know what it is? Whoever printed this for me, I won't name names, but I think this is a little warped. You can kind of see it. It's like, looks like it was lifting off the build tray a little bit. So I might actually switch over to the part that I printed off of the Creality K2 Plus. Because after all, Creality makes a superior product, and will have made excellent print quality here. So let's get this part switched out. Yeah. Yeah, we'll do that. I just have to peel off this brim. Okay, where do we go? Okay. Wish the Cobra 2 firmware was opened up, but it really prints good as the Viper with no... Oh, man. Come on. You can't be saying the Cobra 2 is actually a good printer. You serious? Are you being serious right now? You actually like that thing? To each their own. To each their own. Okay, so we got that. I might as well switch this entire arm assembly over to the polycarbonate version since I have all the parts here. I just need to insert a couple more heated thingies. Now I gotta make sure not to stab myself again. Check this out. Yeah. That's not too bad. I've had worse. Okay. Time for some more heated stabby action. Now, I'm not sure if my soldering iron will be hot enough to push these heat set inserts into polycarbonate. Polycarbonate is a very temperature resistant material. A lot more temperature resistant than this I'm just getting distracted by my other prints I have going. It's a lot more temperature resistant than this PolyMaker ABS or PolyMaker ASA, I think is what this is. The PolyMaker stuff is blended to work at kind of a lower temperature, which makes it suitable for printing with Vorons. Not the best in terms of temperature resistance. So it makes it easier to do press fit inserts, it makes it easier to print on machines that can't handle as high of temperatures or might not have heated enclosures. Polycarbonate, on the other hand, is very temperature resistant. It's one of the best high temperature materials you can get. But it looks like I am able to melt this stuff in there pretty good. One down. It takes longer of holding the heat set insert in place before it starts sinking into the material. Okay, so 2 down, and then is there anything else, or am I good? Let's see, on this one there's 1, 2 pieces. Okay, so I think I'm good there. Turn that off, and we'll disassemble this and reassemble it in the polycarbonate version. Alright, time to switch the gear over to the polycarbonate version I just printed. Using the one and only Creality K whatever. Come on, let's see, this all should go together. It might require some slight bashing to assemble. Oh, oh no! That's really bad. Okay. Alright. Time to play look for the parts that flew all over the office. Yikes. Okay, so we lost the two little bearings that were inside of that. And those are pretty unique parts, so I will have to find them to proceed with the build. Yikes. Big whoops. Yeah, I don't know if that's game over for me or what, but it's definitely bad news. There's two of them that just flew off. How could this happen? Oh no. Oh, here's one. They're these tiny little things. Very hard to track down. I got lucky and found one. Let's see if I can find the other. So I need to follow the order of operations that they give in the assembly manual, and that would prevent things like this from happening. But I thought I could wing it. I got away with it the first time. The second time I wasn't so lucky. We'll just have to find that second little bearing, wherever it may be. Worst case scenario, it fell inside of my air filter. And that would be bad because it would take me a long time to, you know, find it. Oh, here it is. Got lucky. Okay. So, anyways, we put these two in there. What I'm gonna do this time is, instead of doing it in whatever order I feel like, I'm gonna do it in the order that it says on the instructions. So I need the other piece. I'm missing one last piece that's in this smoky color. And parts flew everywhere. Here it is. Okay. So this time I'm going to get this little subassembly put together first. So to get this together, I'm going to give it a little tappy-tappy, just like last time. Okay. Oh, yikes. You know what, this is good enough for now. We're gonna see how this works. Put that there. Push the pin through the middle. There you go. Jeez. Ah. Okay, there we go. Ah. So polycarbonate is stiffer than ABS or ASA. So it's a little bit harder to push these press fits in. With these new parts. But the little effort, we're able to get it. And then let's see what happens when we put this one in. Yeah, this one doesn't bind at all compared to the previous one, which was binding up. So I might have to reprint these again to get the tolerances to be a little bit better. And then I'll get this little piece and hook it in like this. All right. Yep, that's all good. Then we'll put this screw in place. All right, so that was a little hectic. I'm glad we were able to sort all that out without, you know, having to freak out too much. It only required a moderate amount of freaking out, and we're able to get going. So, awesome. Okay, so you don't want to tighten that one down all the way, you just want to like kind of make sure the screw is going all the way through. What the heck? This is binding up too. Maybe I need to loosen this bolt up a little bit. I don't actually understand how this assembly works, because when I push it in, it feels like it kind of clicks closed. I don't really know what's going on here. I can't say I like what's happening. What the heck is this? Oh. Ah, I see. So this little blade surface at the top here goes into a little V slot inside of there, which helps keep everything highly constrained. However, if there's any kind of deviation in the size of the things, the way things should be, then it like starts binding up. So what I'm gonna do is shave off a tiny bit of material up here. Okay, so we removed a little material there. Still binding up. We'll take out a little more. Man, I don't like the way this is designed. If you just... an extruder requires high precision. So why are we printing them? Let's see if I completely cut that feature off. It's still binding up. Okay, this is just, I'm not a fan of this. This is just way too jerky. I don't like it. I don't like it. So someone explain to me why this thing sucks. Can someone explain that to me? And is there any better alternative to a 3D printed extruder? Yo. All right. Okay. Let's do this. All right. So this feels like crap. Putting grease in there is not the proper solution, because you're just masking an issue. Hey. This thing isn't going to work, though. Does anyone know of an easy mod where I can just put a different extruder on here? Because this extruder is just... it doesn't seem great. Slap a Sprite extruder on it. That's a good idea. Okay, well, I'm just going to leave this subassembly as is. We'll put it off to the side, and we'll either need to rebuild this or find some mod where I can substitute it with something else. Maybe I can just do a Bowden extruder for now and like put literally any type of extruder off to the side. But I'm a little disappointed with that. Okay, anyways, let's move on to this part. I guess I attach these two together. This seems like an integral part of the whole system. Like it all needs to be bolted together. Okay, well, we're just gonna move ahead with this the way that it is. And I guess I can... Alright, so I'm going to remove this piece and see if it closes and opens smoothly. Yes, it does. So really this part is the problem, and I can reprint this slightly offset or something, or like sand this piece down to get it to work. Or maybe I can use the original ASA part. That's an idea. Okay, let's do that. I just have to find it. Okay, here we go. Okay. All right. Let's get you put on there, buddy. All right. Oh man, that's just as bad as the first one. Oh my gosh. It would be nice if it could just like kind of wear down and form its own fit, but it's not going to. It's just going to be awful. Well, maybe it'll wear down a little bit. We can try, but yeah. Why would they do it like this? Okay, here's what I'm gonna do. I'm gonna take out the screw here. Any day now we'll get this care of. Alright. Come on, there we go. Then we're going to bore this out to be a larger diameter. Okay, and how we're going to do that is we're just going to force fit this tool in up here. And this is actually getting hot enough to burn me just from the friction. So this is going to allow this to heat up. Not so much that it melts, but enough that it allows for rapid creep. So we get it up above the glass transition temperature, and it'll plastically deform and make that hole a little bit bigger. Okay, now we're going to pull this out. Okay, so now that hole should be a little bit bigger. That'll buy us a little bit of room. That way when we put this back together, it's a little bit better. We can see shiny spots here where the wear is occurring. So basically those are the areas we need to knock some material down. Maybe it was better with the polycarbonate one, so I'm going to switch back to that. Okay, this is a little bit better, but I can still tell that it's being loaded up. Let's wear this in a little bit. Hopefully it'll be... Like, this is really not good. You don't want excess friction in your the way that this extruder locks up, because it will basically make it so that if a wide segment of filament passes through and pushes this out a little bit, there's going to be so much static friction that it's not going to be carried back in by the spring tension, unless I'm misunderstanding how this whole mechanism works. Maybe I am. That's possible. Maybe this is supposed to lock up like that, and then the this piece in the middle is supposed to, you know, move based on the spring motion there. Someone tell me if that's right, because I'm ready to move on from this crap, and I'm hoping that that's the case. Like, how is this really supposed to lock up and close just based on a friction fit? That seems kind of crazy to me. If that's the case, then this polycarbonate, this ABS piece is doing just fine. It's definitely locking up. And if that's the idea, then good. It's doing the thing. Yeah, maybe this locks up and then you still get some flexibility there when the filament's feeding. But another issue we have is this. This feels like it's binding up when that's closed. When it's open, it's free spinning. When this is closed, it's binding up. But that could be just from the gears being too close together, and when an actual piece of filament is down there, it'll be fine. We're just gonna go with it the way it is. Anyone know how? Yeah, well, I've got 300 plus pages of instructions manual. According to the comment from Carmel Zappa, it says, in general, the best tool for building any printer is having the CAD open so you can look at it when you don't understand something. Well, there's a 300 plus page instruction manual here, so I think I'm going to go with that. If you can't clearly explain how to put the thing together with that, then I don't know what to do. Okay, so we're going to put the motor on. Alright, we're probably going to use some 30mm long bolts to get this motor attached. Yeah, M3x30s. Now the key to building a Voron is to not rush it, because if you're in a hurry, you're going to hate everything. You're going to hate yourself, you're going to hate the printer, you're going to hate all the printed parts and the design of everything. But if you slow down and take things step by step, you'll hate things just enough that you'll be able to keep going with the assembly process, but not so much that you're gonna just like quit altogether. All right, so you use one M3x30 and one M3x8 with a washer. Love it. I love all the complexity here. It's definitely making this design better. M3 washer time. My hands are getting shaky. I'm having too much caffeine. I think I should have some more coffee. Okay, so you let that be loose, and then you rotate this so that it's engaged with the gears, and then you tighten it down. Okay, maybe I tightened it down too much. The gears aren't wanting to spin, so we'll loosen it up a little bit. There we go. Now I'm driving the motor with this little gear access point. Everything seems to be running pretty smooth. And when I push that all the way down, it gets a little choppy, but that's because there's no filament in there ensuring the proper gap. When I put a piece of filament in, it should smooth up a little bit. So let's you know, lock that down all the way. We'll feed the filament in. And yeah, it's pretty smooth. I'm pretty sure that the binding that I'm experiencing isn't really an issue. It's just kind of locking everything shut with friction, and then this is able to, you know, move in and out a little bit against that spring. So, okay, Voron people, it's not an awful design. It is somewhat functional, and we'll leave it at that. Okay, so put this together. I'm confused how much I put together before I attach it to the gantry there. Okay, alright, stream audience, what's going on? Maybe just put your hot end parts on the build plate and have the slicer model your hot end assembly for you with organic supports. Alright, we're going to take a little break. A little a blood pressure reduction break. I don't think I'm particularly stressed out, but I do think I deserve a little break after dealing with all that. So, let's take a look at what the printer down here is working on. It doesn't look great. This was printed with a rat rig print profile. I think it's trying to do the support material too fast. Because the actual model is looking pretty good, but the support material isn't looking great. I canceled the 2 side prints. I don't know, most of it's looking pretty good, but there's definitely some parts that aren't being printed correctly. I don't think this is the G code that I made most recently. Oh yeah, I'm printing the wrong G code. Instead of the new helmet one that I printed earlier. I told it to print. Maybe I'll tell it to slow down a little bit. And we'll see how that does. See, like over here, that's not right. This, so I told it to slow down a little bit, maybe it'll correct for that. But everything else that's printing is looking pretty good. It's definitely not the kind of reliability that I would want. I'd want this to be a little more assured of itself. But I'm printing this without using the actual print profiles that they sent me. So there's probably something wrong with it. I think I'm telling it to print using rat rigs profiles, so it's like, you know, this obviously isn't a rat rig, although it's about a similar build volume. So maybe it's going faster than it should for certain features with the hardware that it has set up there. All right. Any questions for you guys in the chat of all the stuff I'm working on? TNX smoked sausage sounds good. Menu's funny. Oh, where's the smoked sausage? Switch to Monster energy drinks. Yeah, and then I'll get kidney stones or something. That sounds like a lovely idea. Why is the extruder that large? Could it not be made more compact? Yeah, this is like massive. I don't know what the, like, it's like a vanity project. They want it to look a certain way. I'll hold it up next to the Creality Ender 5 Max extruder just to have a point of reference. So, actually, you know what? They're about the same. It is larger for sure, but it's really different. You know, the Creality extruder is actually larger when you look at the backpack area. But I do like this little back portion that's adding some additional part cooling. So you've got flow from all angles that way. On this one, you have flow from 180 degrees on this design. Let's get it like that so you can see. So you've got pretty good airflow here. I think on the Ender 5 Max you've got better airflow, and it's a little more compact, which means you've got better packaging. And they're using like 20-watt fans. These fans up here are insanely powerful. Compared to this, it's using a 5015. Oh look, I can't see the specs because, well, let me just take it apart. This is a 24-volt fan. It doesn't say the amperage or the power consumption. So I imagine it's less powerful than these ones though. These are like insane, like turbine motors. This will probably be quieter. So there's that. All right. Love the progress that I'm making though. We've only been streaming for 4 hours, and we've got the hot end. We got the hot end maybe halfway done. Now I have to start wiring it up, so maybe in another 4 hours we'll have that part finished as well. I never really liked the stealth burner setup. It says 666 Nasarima. Yeah. Seems that way. It is very easy to maintain. Really, stealth burner is very easy to maintain. I guess since it's built into those 3 different segments, if you're having an issue with the extruder, you can pull that off and leave everything else intact and be able to work on it that way. So that's pretty cool. Stealth burner predates the idea that printing is supposed to be fast. It was really never the goal for Voron. Sure. Sure, buddy. Yeah, I believe you. Not. The whole thing about Vorons when they first came out is they were faster than the Ender 3 and the Prusa and everything else. Now I just think the expectations for speed have gone even higher than what the Voron is capable of. Just a few screws and you can reach everything? I guess so. Show me where the Voron officially said they wanted to be fast. Well, I mean, if you listen to what they were saying maybe 4 years ago, that I think was one of the stated... Yeah, okay. But still, I mean, you know, it was faster than basically everything on the market back in the day. Like, the idea was never to print at the same speed as an Ender 3. It was, you know, faster, and that's one of the reasons people liked them. Build volume, this is a this is a 250 by 250. So this is kind of a small guy. I didn't want to build the larger ones because the materials I don't think are really built in a way that it's like structurally sound in a large size. It's barely structurally sound in this size. I think it's actually a little too loosey-goosey. Like if you set it down aggressively, then it could bend the frame out of square and you have to rerun the calibration. Also, you know, everybody talks about how 3 lead screws is great. Like, oh, you want to have 3 lead screws. I think 4 lead screws makes the most sense. Like on this Ender 5, you've got 4 lead screws. On the Ender on the K2 Max, you only have 2 lead screws, which I actually don't really like. I think it should have 4, especially with how expensive that machine is. I mean, I would expect a little bit more strength and build quality out of it. But it's actually fine. Like, it hasn't had any issues with any of the prints that I've run. I just think it would have been better if they put 4 lead screws in there. Yeah, it makes the bed a lot stiffer when you have 4 lead screws instead of 3. You can think of it like, here, I'll show you. You can think of it like a car. Like with a car, you've got 4 wheels on the ground, 1, 2, 3, 4, and then no matter which way you're turning, or if you're braking or accelerating and turning, you've got like a lot of support. When you have 3 lead screws, you've got this from here to here is very stiff, but out at these corners, it becomes quite a bit more flexible, because when you press on this side, it's going to want to twist this whole plate. And Vorons have mostly gotten around that issue. Sorry, don't want to do upside down. But Vorons have mostly gotten around that issue by using a really thick plate, so that it's really stiff, and when you push down on this corner, it's not going to want to twist. But when you're using a thinner bed, like what you have on this Ender 5 Max, that wouldn't work, because if you push down over here with 3 supports, this would act like a springboard. Like, you draw a line from here to here, from here to there, like, you know, like right along here between these 2 supports. The further away you get from this line, the more springy it's going to be. But since this is so incredibly thick, you know, it's almost a centimeter thick, this ends up being well supported. But if you were to use a thinner build tray, something a little lower cost, like what you would want in a mass-produced good, then you would definitely want to use 4 supports. That's just my opinion. And the 2.4 uses 4 supports. Hold on. Yeah, the 2.4 uses 4 supports for the gantry, the flying gantry system. Just like this does. It's using 1, 2, 3, 4. Right? Because the gantry isn't very stiff. It's actually pretty loosey-goosey. And having 4 supports is the only way to make it work. Unless you were to stiffen everything up, then you could drop down to 3 supports, but really that's yeah. You run into the issue of okay. Alright, let's see. 3D Printing Maniac is a Ender 3 5 Max equals K1 Max build plate thickness equals warping equals no innovation equals usual Creality. Well, this has 4 lead screws, so it's going to be a lot stiffer, despite it being the same bed thickness. Yeah, I haven't done a whole lot of prints on this yet. I'm going to do some more soon, but I don't think it's going to have any issues. It seems to be well built, in my opinion. But time will tell. We'll fire up some prints once I get the right slicer configuration files from Creality. Alright, so let's keep on building. Let's get some more stuff going here. So, where were we? We've got this tool head pretty much completely assembled. I think actually the original ABS parts were probably fine. They were a little bit warped though. So yeah, maybe I'll end up reprinting some of the parts of this printer once I get everything working. It'll be a little bit more, I'll feel a little bit more sane working on this printer once it's actually like, it can actually move and is all wired up. I just feel like it's crazy to put so much time into something that's not even printing yet. Okay, so where do we go from here? Let's consult the manual and see what's the next steps. Alright, so I need to put the cable chain holder on the back, behind the motor. So this thing, I guess, goes back here. Okay, gotta use a M3x20. You know, this is a case where they definitely could have standardized some more screw sizes. There's no reason to be switching between M3x20s and M3x25s all the time. Okay, there's that one. And on the other side, I'll use an M3x8. Alright, I'm gonna throw up, I wish I could add a poll to the live stream while we're going here, but I want to hear everyone's favorite fast food chain. I need to know what kind of junk food you guys like to eat. Is it Chick-fil-A? You like some Nando's Peri Peri? What do you like? Okay, there's that. Okay, now there's a secondary latch thing, which is what we printed out earlier. And that goes up top. Okay, this goes together somehow. I can sense it. My superior design skills have prepared me for this moment. Okay, and then this goes in with an M3x16. Not an M3x20, an M3x16. All right, there we go. Oh yeah, I need to plug in my phone. 1 second. I'm probably putting this in backwards. Oh, no, this looks like it's right. Okay, that's kind of cool. There's a lot of friction in this system, but that kind of locks it up. Not my favorite, but it'll do. I'm a little confused on how this screw went in, because I was just spinning it, and I don't think it ever tightened down. So this screw right here, like this is just spinning freely, so what the heck is going on there? Is it an M3x16? No, the M3x16 goes up here? What? Did I miss some heat set insert locations? No? What the? Okay, so the M3x16 goes through here. So I just have like a sticking out the back. And then I guess the M3, this top latch should use a longer, yeah, M3x30. No. Well, M3x25, okay. That's what it felt like should go in there. So M3x25. Oh god. Okay. Very cool. Wow, that is very clicky. Wow. Okay. Nice. All right. Okay, so this, how does this go? It's like this. Seems about right. Okay, next. Got to skip some parts here because I don't care about the LEDs. So waste of time. Got the fans, cut the fan up. So now I need like a little thing to hold on to this probe that goes back there. It's like a little piece that has two heat set inserts put into it. I don't think I have that. I don't think I have that piece. I probably have it printed somewhere, but I don't know where it is. Alright, let's see what kind of junk food you guys like. Induction stove tops are great. H2D? Ah. So is there anything confirmed about the Bambu Lab H2D? Is that even what it's called? Or are you guys just going off of months old speculation? H2D, 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 H2D. Okay. 3D Print Maniac is going a little too crazy. Let's look up H2D. It's a hair care extension. Alright, I'm looking on the Bambu Lab community subreddit. Yeah, there's nothing. Sorry, 3D Print Maniac, thank you for timing him out. Alright, you gotta calm down, Maniac. You need to chill, alright? We're trying to have a civil conversation here. Pickled bamboo? Are we talking about bamboo shoots? Let's see. Alright, next up I need to print the little piece that goes in the back of the thingy there. So let's go back to the Voron Stealth Burner. Main body diffuser, nah. Technically part of the Voron Trident. So if we go to the tool head, I hate going into these files to find things. STLs, spool management, skirts, panels, electronics bay, Z assembly, probably in gantry, X-axis, AB drive units, front idlers, probably X-axis, X carriage, probe retainer bracket, Yeah, that's what I need. I'm going to download probe retainer bracket and probe retainer bracket 9mm. I'm sure one of those will work. Okay. Let's go back to our Creality print so I can manage the greatest printer in the universe, the Creality K2 Plus. Proven supremacy. All you Creality haters out there can frick off. Okay. So we'll print these two little guys. Slice and export. Alright, this little print job will take, I don't know how long. I'll call it tiny print. We'll export the print job to our little flash drive. And we'll get it printing. So it looks like it's going to take 17 minutes to print two of them out. If I was a little more discerning, I could... Hold on, let me just get this started. Derp. Why is the USB port so far away? There we go. Okay. It's all the way over there. Alright. We'll print another thing. Alright, so we're firing that up on our K2. The most amazing printer in the world, the Creality K2 Plus. It's my favorite thing to talk about because it just triggers the Bambu Lab fanboys so much. Isn't it funny that Creality makes the best Core XY machines on the market right now? We'll wait until I get a Core 1 in for review. But, you know, that one will be pretty cool in a different way. But in terms of just giant Core XY machines, look at that. Creality's dominating. How does it feel, Bambu Lab fanboys? You've been waiting for years to get your giant Bambu Lab Core XY, but Creality's got it right now. They're just ready to deliver. Look at that. Look how speedy and full-featured this thing is. Yeah, 110 degrees on the build plate. This thing's crazy. Okay. Anyways, let's see. What can we do here? What do we do? What are we doing? Alright, we're going to get those printing. The giant Tronxies? The Tronxies could be good. I don't know. Make that IDEX and we can talk. Okay, fair enough. I think we do need a giant Core XY IDEX, or at least dual extruders, but all right, so we'll get those printed out, and we can continue this build. Let's see what else I can do here. Damn, this is such a long process to build this. Man, I would not be able to do this if it wasn't for the LDO Voron kit. Because imagine me sourcing all these parts individually and not even knowing if I have the right hardware to do this, or I get some crappy parts. Like, all the issues that I've been struggling with have to do with the printed parts. But imagine I'm having the same type of issues with all the hardware, like I get the wrong length linear rails, or I buy the wrong board or the wrong extension cables. I could imagine that being a totally miserable process, and you gotta give props to LDO for making an awful process that I wouldn't wish on anyone just a little bit nicer. So yeah, all this wouldn't be possible without LDO. So thanks LDO for sending the kit over. We're gonna keep on going though. We're gonna get this done. I want to see a Delta tool head changer. That'd be insane. Yeah, that would be nuts. Delta tool head changer. I don't really like Deltas in general. Lost in Tech, who was in the chat earlier, did a video where he showed, I think it was one of the most recent videos that he's done, but he showed in slow motion the Delta printer. I'll just get in the whiteboard area for a little bit so I can explain. This is where I explain Delta kinematics in my last video. So you have a Delta printer. I'll just draw it in 2 dimensions to make it easier for you guys to understand. But you have a Delta platform here. And then you've got your carriage. And then, you know, you're able to move these up and down to get this to move left, right, up, down, and in and out of plane in the 3-dimensional case. But essentially, these are what you call 2 force members, the actual beams that form a parallelogram that allows you to, you know, move everything around and have motion down here. It's always a parallelogram. And these beams are 2 force members, so they only carry tension and compression. So when you have it accelerating that way, and then you want to come to a stop, this one pushes on it. There's like this sum of forces calculation that you do a lot in engineering. But if we just like chop these off in the middle and see what it takes to produce the correct forces, when I want to produce a force pushing to the left there, basically these 2 have to push against that force, and these 2 have to do a force in the opposite direction. And all of this needs to add up such that this plus this equals this. And what you end up with is a situation where, let's say you need to produce 100 newtons of force in that direction. When you break that down into the component forces needed to add up to this, these forces end up being something like 200 newtons and 200 newtons, just because of the way the angles work out. The shallower this angle is between these two, we'll call it this angle, you know, like this angle here, we'll call it theta. The shallower that angle is, the larger these forces need to be to produce the same acceleration. So it's really not ideal, and what ends up happening is you have these large forces going like this, and it's going to cause this to wobble. Like this will want to shake around like this. You can imagine the print head shaking around when you're accelerating, and it's going to be twisting like a clock, and you could see it pretty clearly in Lost in Text video. So it's not ideal. If you compare that to a normal Core XY system, or like a normal kind of gantry system, where you have a print head and you're moving it back and forth this way, the acceleration forces required to move the print head are going to be exactly the same as the forces that you're pushing through the belt. So, yeah, and then not only this is you have to do a third transformation to get from the tension and compression forces on these beams into the tension and compression forces on the belt. So, you know, you start with 100 newtons here, you end up with 200 newtons here, and then you have to, you know, create some component of that in this dimension. You end up with like this kind of, you have to look at the angle of that. And I guess you have less force required by the actuators there, I think. And then you have a certain component of that introduced into this beam as a sideways force. So if those beams are really long and skinny, then they're going to act like a bow, like a bow and arrows, like this. You know, it's going to want to wobble back and forth like that, like boing. So that's why on the S1 Pro, these beams had to be so thick, because you're introducing a bending force into them, which is like the weakest way that a beam can be loaded. Compared to, I guess, on a regular type of gantry machine where, you know, this is X and this is Y. You actually have the same type of thing where this beam is going to get loaded and bending, but you can just make those thicker. And I think because of the angle thing where the forces kind of get amplified, might be worse here. I'm not sure. But it's easier to reinforce these and make them stiff because there's only two of them and it's all like in the top frame. You just make the top frame super thick. Versus this, you have to make the entire vertical piece of the printer super thick. So, I don't know. It is what it is. Let me erase this. Okay, so we're going to go back over here. Oh, the other thing that I want to point out is that when you have a beam, this is like a basic thing in mechanical engineering, where if you have a beam, so this is our beam, you always imagine it as like a one pin and one roller, just so that it's not carrying tension when you load it like this, because it just makes the calculations more complicated but doesn't really change anything important. When you add a load to the middle of the beam, this length is huge in determining how stiff the cross section of the beam needs to be. So if you start with the length of the beam and then you double it, basically the amount of deformation introduced from a load, so you introduce a force here, pushing down, the amount of deformation is proportional to L to the third. So if you double the length of the beam, then you're going to get 8 times as much deformation out of that. So that's why when you make a big printer, it's so much more difficult to do, because the big printer needs to be 8 times stronger in order to have the same type of performance. So yeah, that's why, you know, that's why I'm impressed with the Ender 5 Max, because it's basically double the size of the smaller printers, but it's still a relatively lightweight package. So they had to be pretty efficient with the way they designed that thing, structurally speaking, to be able to still get good print quality out of it. So yeah, that's that. Any questions from the class? Anyone? Bueller? No? Okay. All right, let's get back to work. All right, thank you, Tunke, for the thanks. You're welcome. So yeah, these aluminum beams up front and out back, they have to be very strong to have this thing work the way that it does. And you know, these rods are like, you know, pretty thick to have this work out. But it feels pretty good. Okay, back to the Voron. And back to this amazing printer, the likes of which have never been seen before. Creality's most original design ever, the K2 Plus. Can't wait for the K2 Max, you know. They're calling this the Plus, so of course there's got to be a Max version. How big do you want the Max to be? That's a good question for you. How big do you want the K2 Max to be? Should it be like the size of a washing machine with like a 550 by 550 build area? I think 500 by 500 would be, people would be pretty happy with. All right. Those two little parts finish up. As big as a fridge. All right. And like a meter, 2 meters tall. All right. So let's get into this. Right now, I think I'm going to put together the Core XY stage, and then it'll just be a matter of wiring everything up and getting this thing running. Whoop-de-doo. I'm going to check the chat. Yes, Hexacon, this will be on the test, Hexacorn. Something's got to beat the Orange Storm Giga. The Orange Storm Giga is like a meme build. I don't think it's very serious, and I just saw a video from Major Hardware, who's a notorious Bambu Lab shill. No, I'm just kidding. He's not a shill. He's more of a fanboy. He really likes his Bambu Lab printers, but he wasn't too happy with the Orange Storm Giga. I'm still, you know, or they told me they were going to send me one. That never happened, so, you know, not happy with Elegoo about that, so that's part of the reason why I didn't review the Alpha Centauri Carbon or whatever. You know, they wanted to send one over to me, and I'm like, I mean, it seems kind of a boring machine. Do I really want to spend whatever amount of time working on that when essentially it's just, I mean, compared to some of the other printers that are on the market, I feel like it's not as exciting. And how much is it? How much is the Alpha Centauri Carbon? Yeah, the Centauri Carbon, they announced it like a year ago, and they're finally coming out with it now, which I guess is good. Like, you know, you want to come out with it when it's ready, not when is the best time for the market. Launching things too early is going to cause a lot of issues. All right, there's some more perfect little pieces off of our K2 Plus. I wasn't kidding when I said that was like the actual printer that I'm going to be using for a majority of the stuff I do in my lab. At least for now, like out of all the machines that I have access to, it's the most capable, it's the easiest to use, and you know it's relatively large. Can do high temperature stuff, can do multicolor stuff if I really want to, which I don't really for the most part, but you know, having that AMS, oh, I'm sorry, the CFS. This is not, it's not an CFS. Having that is actually pretty convenient with having the multi-material capabilities of, you know, being able to automatically switch to the polycarbonate and switch back to PLA or whatever else I want to print with. Okay, so you could have built a shed out of that thing, camping. Oh yeah, that would have been hilarious. Yeah, like go ice fishing with the Orange Storm Giga. Just sit on the, put some panels on it and sit on the heated build tray. Put a little solar panel on top with my, that would have been fun. So, CFS greater than AMS? I don't know about that. They're pretty much the same thing. I haven't used the AMS that much, but like, it's basically the same thing. I mean, sure, it has a couple extra features built into it, so like I would say maybe it's marginally better, but they're basically the same. I wouldn't be disappointed with one over the other. Oh, actually, the AMS has a huge downside, and that is that you can only use it with Bambu Lab printers, which basically disqualifies it from ever being used in my lab. So, AMS 2.0 comes this year. We'll see about that. They're professional FDM that size, but they have a few extra zeros on the price tag. Yeah. I feel like professional means that they just gouge you on the price and give you proprietary filaments and are selling to people who don't care about how much waste is involved with the cost of the machine. Alright, so we're going to do some more heat set inserts. Let's do it. Alright, and let's see which one of these lines up with the holes that I need. Looks like this one. This one's too small. So I just printed out both variants so I had the right one. Looks like the one that's more spaced out is the one that I want for this kit. Here we go. All right. Okay, here we go. Put that down so you can see some heat set insert action. I gotta hold these in place for like 10 to 20 seconds to get enough heat into them to melt into the polycarbonate. All right, there we go. All right, now we're going to, here we go. We're gonna set up all good over there. We're gonna put this sensor in place. All right, that was pretty easy. Alright, what are you guys watching on YouTube? Is it all 3D printing content, or you like some weird stuff? Some video games? Some conspiracy theories? Politics? Tell me what you guys are watching on YouTube, other than this amazing whatever's going on here. Proximity probe all plugged in. Now it's time for the next step, whatever that is. Alright, so this is supposed to be, oh dear, this is supposed to be 6 millimeters. I don't really like the way they did this drawing. Is this 9 millimeters or is it 6 millimeters? I'm guessing it's 6. But, you know, help me out a little bit here, Voron. Videos of Jordan Peterson getting stomped in debates and being a nut job. Oh, well, yeah. Yeah, he definitely used to be a little more coherent. I don't know what happened to that guy. Alright, well, let's put this together here. I think I just need to cut these belts. I'm a little worried about cutting the belts. This looks like about 6 millimeters. Yeah. Time to cut the belts. What else are you guys watching on YouTube? Bambu Lab conspiracy, yeah. I don't know. Bambu Lab is they're not good people, if you ask me. They kind of gaslight and lie about what their true intentions are. I think what they want to do is just dominate the entire industry and have a captive market where they shut everyone else down, and you know, you're forced to buy their products. And everything they've done leading up to this point kind of points to that, but they don't want to come out and say it. In Dr. Tao's work, went to the CNC Kitchen interview, he was like, he asked Stefan from CNC Kitchen was like, is Bambu Lab evil? And he refused to just say no. Like, that's a pretty softball question. If someone asks you if you're evil, just say, no, I'm not evil. But instead he went into this like weird thing where he was like, well, I can't just say I'm not evil. You should look at what we do and then judge whether we're evil or not. And it's like, okay, yeah, you guys are definitely evil. if you wanna be that way. All right, so let's see. I watch tons of educational content. That's good. Very good to do. Watching videos of camping. That sounds fun. Maybe I should do some camping content. I've got the solar generator. I got that, what's it from? I think it's Jackery. I've got like a 2,000 watt-hour solar generator. You could definitely go out and do some more 3D printing in the wild. Okay, but let's get this going here. What do I do next? Looks like this goes up. That goes up there. Looks like I need to do some heat set inserts. Any day now. This is going to melt in. Just got to give it like 40 minutes. Off-grid living, they would love 3D printers, eh? Yeah. If I was living off-grid, like if you were living off-grid, what 3D printer would you want to have? And what would be important to you? I mean, you'd probably prioritize reliability and a good offline workflow, since, you know, unless you want to do Starlink, you're not going to have internet out there. But also, if you're living off-grid, you probably take privacy pretty seriously, and if that's the case, then you probably don't want to do cloud stuff anyways. Lots of woodworking stuff. All right. I want a big industrial printer. I can print any material I throw at it if I'm having a printer living off-grid. Yeah, maybe like something that can take wood pellets. I know I still don't have, but still have the same market share. Something big and enclosed, you're more likely to have high temperature swings. Yeah, probably. Yeah, you'd need, I'd probably want to have a rat rig, but also portability probably makes sense. I think reliability is really important. Oh yeah, Blacktail Studio. I was watching his one of his videos this morning, the scammer one. That was pretty funny. Someone did an AI-generated scam call of himself, like being annoyed with someone for not falling for the scam, and then like forcing them to, like, trying to get money. Like, oh yeah, just pay me $5,000 as a deposit. But it's really freaky what you can do with AI-generated videos. Ooh, Pantheon, that's a good idea. HT90, also a good idea. Those would be pretty awesome. When you want to be able to make your own filament. Yeah, maybe something with a pellet printer so you can recycle your old prints, or you could come across like old bottles and turn those into useful parts. Alright, so, or there's got to be some kind of biopolymers, maybe a glass printer, or like something that can print with pitch or wax or something. Power efficiency, I was thinking about 3D printing from a van. 3D printing in a van would be pretty nice. I think you found the Prusa Mini to be the most power efficient. Interesting. I would think that something with an enclosure would be more power efficient because you'd lose less heat from the bed. But also having the bed be as small as possible is going to help with power efficiency. Okay, let's see. And also having less powerful part cooling fans. Like you want to turn your part cooling fans down. Let's see. Alright, so I think I'm ready for the next step, whatever that is. So, what is the next step? Oh yeah, heat set inserts, got those in. Now we're going to attach with an M3x8. Down. Okay. Okay, that's all plugged in. Got those two bolts bolted in. Alright, time to put the bottom half on with M3x50s and M3x25s. Alright, two M3x25s. And some big boys, M3x50. These M3x40s. We need the biggest screws possible. M3x50s. Boom. Alright. 3x50. Huh? Okay, how does this work? Okay, so you just, oh, okay. I guess that cable goes up here. This goes in there. Okay, I'm doing something wrong with the cable management here. I have to undo some screws. So one of the reasons why I don't really do giveaways on my channel is I think it would like prime people to be scammed. I don't know. I've done giveaways, but it's always in person. Like if there's, if someone needs something and I'm around and I have an extra printer, then I'll just be like, here, take the printer. But in terms of up for online giveaways, I feel like that kind of indicates to your audience that like, hey, maybe I'll give you something. If you're a good fan, boy, or something. And I don't want to get involved with that kind of stuff. Okay, so that's in. I'm going to put the front cover on. Here we go. Okay. Alright, two screws there. All right, another screw here. So how many streams does it usually take people to build these things? This is my second stream on this build so far, and I've done a little bit of work off stream. That's looking good. Rate my work. Yes, this would be faster in the back of my car, for sure. Get that tension set. Man. All right, that's good. What next? What are we gonna do next? I think it's time to, I don't need the ADXL mount because the little circuit board already has that built into it. I think I need to start putting the PCB and stuff into the top. So we'll figure that out. Now, you guys tell me if this looks problematic. What's going on here? Is that normal? Over there too. It seems like everything's going pretty well here. Except for these two side pieces I canceled. For some reason, well, I know the reason. I loaded up the wrong G code. And it's not actually using the mesh bed leveling. So it's kind of, I mean, the bed's relatively flat because of how thick it is. But yeah, it wasn't laying down these layers too well. But the middle was looking good, so I just canceled the two side pieces and I'm letting the middle run. But is that okay there? I'm kind of confused. It looks like it's printing fine, so I'll probably just leave it and let it run. Okay, you've got them. Why would you bother to tune that out in the print profiles? So yeah, if you're saying it's okay, I'm gonna say it's okay too. But what are we gonna do next? I think it's time to set up the Neverbore PCB and get the wiring all squared away. It's insane how long this takes. Like, I've been streaming for 5 hours and I just finished this thingy. That's all I've done. Yeah, no spaghetti so far. So we'll let this one run. I did some tests. Oh, I crashed? No, I didn't. You crashed. You crashed. I'm not crashing. I've got all the data and analytics. Oh, maybe it's because I switched the webcam front to back. Okay, so let's do this thing. What's up next? I think it's time for me to figure out how the PCBs in the tool head are supposed to be set up, which I'm not looking forward to, but if we're at that step, then we got to do it. So back to the Voron Trident assembly manual. I already put the electronics down there together. For the most part, this all has been done. The controller wiring, we'll do that after I get the print head set up. Okay, here we go. Now, my printer is going to be different because I'm using the Nevermore thing. It's like the CAN bus setup. So I'm not using directly to the control board. It's actually going to be hooked up to the top. So let's see what we're gonna do here. There we go. Okay. So it looks like we need to get the crap. I need to move these a little bit. Just moving the belt so that it gets the full range of motion. Okay, and I'll put some of these little screws in there. Sorry, I'm not showing you what's going on here, but this part's kind of boring, so I just want to... crap. I'm just getting the belt to behave. And I dropped the screw, so we gotta find it. Oh crap! The screw. I found it. It's in the. It's inside the power supply. So that is one risk of having this power supply open like this. Is stuff can fall in it. I'd kind of prefer this to be face down. So we have to figure out how to get that screw out of there. Or we can just leave it and hope it all works out okay. So I have the inverted electronics mod. Okay, that's not working. I need some help from one of my little Among Us figures. Mr. Among Us will help me. Maybe this will make it magnetic enough to lift up the screw. No. Here, how about now? Come on. Let's get this. Frickin'. I don't want to have to turn everything upside down to get this out. Okay. Come on. How about now? Ah, yes. Oh. Yes. Yes. Ha ha ha. That's great. Okay, that was fun. Too much fun. I'm having too much fun over here. Okay. Alright, Attilo, thanks for watching so far. I have no idea how long I'm going to keep going. I might be going all night until we get this thing done. It would be nice to actually boot this up and get it hooked up to the Wi-Fi and get that going. You're welcome, Attila. Thanks for watching. Okay, so that's all wired up, or hooked up. Let's see, I can't zoom out any further than this. Ah, yes, keep going so you can finish your laundry. That's a good idea. Good call on the Max 5, looks nice. I haven't even done anything with the Max 5 though. Okay, let's see. Whew, any more stuff to do? We need the Nevermore. So this goes down here, and then this goes up the side. Pretty sure this is how this works. It goes up the side. Just like this. Oh, you can't see this. Hold on. Hold on. Alright. So we've got our CAN bus cable. That's going to go up the side in this little slot. Hop over to here. Go through a little channel. Let's cut into this little thing. Untangle it from this. Go in the side here. And up top it goes through all the cable chains. Oh no, I can't fit through the cable chains. Oh no. Oh. So this means I have to unlatch all of those. I don't want to do that. Maybe this connector will go through the cable chains without having to take anything apart. Because unlatching and relatching all those cable chains doesn't sound fun. I think this might work. No, it barely fits. Okay, thank goodness. All right, there we go. Let's get this going. Yes. Yes. All right, then I'll loop it around this. And then can it push around the corner here? Unsure. I'm gonna move it all the way to this side. Push it along as far as it'll go. And then move that so that now it's around the corner. And will it push through? Maybe not. So what I'm gonna do is pop some of these open. Yeah, we'll get it. Alright, so I just pried a couple of these open. Move that all the way to the side, so now I've got a straight shot through there. And down the cable chain it goes. Lost in Tech decided to show up. Well then, I want to see you build this as a slave of 3D printing in one go. I've tried that. That's what I was going to do the first stream, but I only got this far. Oh my gosh. What? This last link is narrower, so something you can actually do is pop these apart. Why is this last link narrower? Are you seeing this? Like it's a certain width right there, and then this one's thinner, so I can't get it through that piece. So I'm going to have to pop this apart. There we go. Push that through. And then reconnect. Ta-da! Alright, we made it through there. There we go. You know what? The cable chain is as wide as it needs to be, which is perfect. Okay. Then we'll loop it around and go in here. Okay, and you're gonna get a long view over here now. We've passed the point where you get the close-ups again. Alright guys, I'm going to get another snack. I need you to vote on what I get to eat. So, what do I get? The acceptable options are string cheese, yogurt, a banana, which Zombie Hedgehog generously paid for. He's a saint. Maybe something else? Maybe a can of soda? A can of pop? Come on, buddy. Almost through the cable chain. So how long does it take people to build these again? Am I exceptionally slow, or is this just the Voron experience in full display? Come on. Almost there. There we go. Yes. Almost there. Same thing, I need to pop it off for the last chain. Last link for the chain. There we go. Oh god, that's mangled. Oh no. I hope that still works. Okay. Okay. Ta-da. Okay, there we go. We're going down. Yes. Okay, all done there. Now what do I get to eat, guys? If you're in for a long, yes. 7 to 10 streams. Wow. Cook pizza on the Ender 5. Ooh, yeah. The K2 Plus would be the more likely candidate, because I'm not sure what its max bed temperature is. Let me look it up. K2 Plus max bed temp. Let's see. It can go up to 120C, versus the Ender 5 Max can only do 100C. Or I could overvolt it, do my own thing, unplug the thermistor and like pop it off there a little bit, or like put a washer between the thermistor and the actual heated bed. So are Bambu Lab printers still on sale? Because they've been on sale for basically ever at this point. The only thing that's going to end the Bambu Lab sale is Trump tariffs. Looking retro next week, zombie. We're all going retro next week, zombie? I didn't tell you. James the Printer. I recognize that name. James the Printer. No content, eh? Nero spends 80% of the time ranting into the camera. That's true. I've only spent about 30% of the time ranting into the camera, so I'm on track to be a little bit faster. Yes. Yeah, I would like to do a Scratch 3D printer build as well. Definitely. I've done one already and I had a really good time with it, and the video performed pretty well. The only problem is the printer itself, and the process of building that cost probably around $6,000, and you know, it's not very sustainable to like that for the channel with the way things are financially. But it was a lot of fun, you know. I'm down to do a crazy project like that every now and then. Zombie still has my trash can. That's great. It's missing some pieces. I didn't realize someone was gonna want it, so I threw like a couple of the chunks, the shards that were missing away. It was like in Breaking Bad when Walt White had some guy locked up in the basement, and then he dropped the plate, and then put the pieces of the plate back together, and a chunk was missing, and he knew someone had it as a knife. And he had to do some awful things that he would have never done in Malcolm in the Middle. Okay, but speaking of knives, I don't know if this content is legal in the UK, so Lost in Tech is going to have to avert his eyes. But we've got some let's see, where'd they go? Some 3D 2A in my own way. Where'd they go? There we go, this thing. Huzzah. Watch this, guys. You ready? I should do some more fun stuff with these, because this was printed on the K2 Plus. Everything that I do on this channel turns into a K2 Plus commercial in one way or another. So, gotta watch out. Alright. Yeah, obviously knives are legal here. The kids broke the super large trash can. You just need to print it thicker. Right? Okay. This print is looking pretty good. It's actually set up to run pretty slow. This thing right here. I have it set up to run slow just because I want to see what a nice print looks like the best print quality I can get. So this is going to be running for the next 3 days. I could like speed it up if I wanted to, but I'm happy to just let it print slow and see what I can get out of it. Then we can push it a little bit faster later. Like I'm already pushing the print volume pretty aggressively by making a pretty large print as like a first actual print on this machine. So, you guys didn't get back to me on what I can eat, so I'm just going to have the banana, courtesy of Zombie Hedgehog. Selling them nowadays to kids is prohibited, even if it's a small kitchen knife. Huh. Well, you can just have your parents buy you a knife. I was in France recently, and they have, they sell knives for kids. Like, they're not specifically marketed to giving to your kids for, like, cooking and stuff. Oh, Zombie, he gave me another banana. My gosh, the generosity of this guy. Maybe next one I'll be able to get an organic banana. It's not a cut, it's a tool, yes. Alright, banana time. Thank you for the banana. Just the peel. Okay, I'll eat the peel. So, got most of the wires, most of the components are set up here. Now I just need to get all the wires plugged in, and I think I'll be able to turn it on. This thing's printing. Is the model out there, the one you just showed, or is it your own model? No, I found that one on, it's like a pretty old model, probably off of Thingiverse. I think it's called like a Tanto blade. I don't know if that's what they call it online. But it seems pretty nice. It's very stabby. Ah, a peach. I'll see what I can get for that. Bear with me. You're gonna have to watch the Uri1 Thinker print for a little bit. Just a moment, okay? I hope this is adequately entertaining while I go grab something from the kitchen. Just a moment. Maybe about 2 minutes, I'll be back. Alright, I got something. It's not quite a peach, but it's the closest thing I could find to a peach. Strawberry yogurt, almond milk. So we're gonna go with that. I also have some human filament, if you know what I mean. Some of this. It's a 1.75 millimeter filament for humans. So maybe we can give that a try too. Alright. Hopefully this is still good. Does almond milk go bad? Probably. It smells okay. Looks weird. But we're gonna go with it. Boston Tech. Different place. Human filament. Well, yeah. I mean, are you talking about the incoming stream or the outcoming stream of human filament? Because you don't want the post-extruded stuff. If we're referring to like what a multicolor unit will do to it, we call them poops for a reason. Nissan paper bowls. I visited Japan recently, and I was on the bullet train, and we went past the Nissan like headquarters and factory. I thought that was pretty cool. I like when you go to new places and you see all the companies that you use on a daily basis. Like the first time I went to the Bay Area, you get to see Google buildings and YouTube and all that stuff, and Oracle and everything like that. Out here, yeah. Is this a room in your house or an office building? I'm at an office. That'd be cool if I had like giant glass walls in my house. But if this was my house, then I wouldn't be able to throw rocks or throw stones, you know, because if you have a glass house, you can't throw stones. Oh, cool. Yeah, that makes sense that they would have a Nissan factory in America too, because shipping all those dehydrated noodles across an ocean doesn't really make sense. Let me see where mine's from. This is from Seoul, Korea, or Seoul, Korea. So I have some Korean noodles here. Bamboo fans at your door riding? Yeah. Used to bike ride across to a town nearby that had a cookie factory. That sounds nice. Yeah, I mean, we have a really strong car lobby in the U.S., so they don't like, you know, non-car based transportation. The only like actual decent train line in America runs from D.C. to New York, and everything else just kind of sucks. It's very slow. Like, if you look up how long it takes to get anywhere by train, it's usually faster to just drive, which is like, I don't know, not the point. But also there's like cross-country flights and stuff. But also, you know, America's huge, so you're talking about thousands of miles for a lot of these journeys that you need to do to get around in America. All train companies have to hire union workers, lots of cost. One of the coolest things about the bullet train I saw in Japan was like all the employees when they walk between the cars, they bow to the car as they walk in and walk out to the next one. They like bow, so they're like, it's kind of like I don't know what it is. If it's like walking from one train car to the next. Is oh, I thought we were building a Voron. Okay, let's start building. But yeah, anyways, lots of cool little things culturally in Japan. All right, let's. Also, you can drink on the train. You can bring your own booze. Versus, I think on Amtrak they don't like that. They'll get mad. They're like, "Wah, you need to buy our overpriced wine and crappy beer." Okay. Anyways, so now I think we need to do the tool head and plug in all the stuff up here, so that this part can talk to this part. So let's get going with that. I'm actually going to get some hot water for my noodles too, because the noodles are going to sustain me. And eventually, once I eat all the noodles, I'll feed the printer some filament plastic noodles as well. Okay. They did cross-country rails how long ago? There's no reason we couldn't rebuild improved lines now. They won't improve railways there cause airplane customers will go down. Yeah, but maybe there should be less airplane customers, you know? Isn't it much more efficient to fly, to use the train? Like, you can have all the trains run off of electricity that's generated, like, by windmills and solar power along the way in those rural areas, so you don't even have to transmit the electricity very far. Yeah, but they need to get started and put a couple more train lines in, like between LA and oh, audio's muted? No way. Let me see. Oh no, audio. Yeah, I can hear it. I don't want to create a feedback loop situation, but all right. So it's time to do the PCB stuff. So let's go. All right. So we've got two fans, a motor, and the heating element. So I haven't put the heating element on, but I'll just do that now. It's just a little Revo core with the little Revo thingy-majigger. We'll put that on. And I'll move the bed down. It's not muted, you guys. I can hear me. Okay. Here we go. Now I have to move the bed down, so here goes. Okay, that's down. I'll attach our little Revo nozzle here. Oh crap, where are these cables supposed to go? Why didn't it have me route those earlier? Are you kidding me? Well, now it's time to see how easy this thing is to take apart. Delicious cup of noodles. Delicious. Ah, yeah. Thanks to everyone who's donated to the stream. I'm officially net neutral in my my food consumption. Actually, I think you've maybe even paid enough that I can have a burger tonight, so that's gonna be great. Maybe some shish kebabs. Noodly 3D printer live build videos. I do miss the smoking section on Amtrak. That was the best place to mingle back in the day. That sounds fun. Now they don't let you smoke on trains. So would you smoke back there, or did you just like hanging out with the smokers? Just gotta route these Revo wires up there. Has anyone made like a mod that lets you use magnets to hold these on? Because magnets would be pretty convenient. Come on, give me that. Okay. That's not coming off yet. Alright. I gotta take all this apart. I don't think the instructions said anything about routing this wire internally. Though, for basically every build, you're going to want to do that. So, what's the big idea? Oh crap, now I have to undo more screws. Okay. Gotta take those all the way out. Alright. And then, where do I route these? I guess up the left side. Okay. More JST termination kits. Our turns are pretty awesome. Big car though, so no smoking. People don't go back and smoke though through in between their cars. Oh, okay. Like in the open air between the cars. Most I don't know, what country are you from? Nasarima? Ferries around. So you have ferries, trains, and everything. Pesky patriarchy blasting rocks and occasionally themselves with dynamite. Yeah. Hello from Sweden. Yes. What's JST? JST connectors? Yeah. Not that expensive. Alright. Alright. Hopefully that's all good. Okay, next up. I'll put these two screws back in, which don't really seem necessary, but whatever. If the instructions tell me to do it, I'll do it. Okay. And put this back in place, and then put this back in place. I've earned myself a cup of noodles at this point. Voron mentioned to press the like button. I only see 5 likes. That can't be right. Hold on, I'm going to refresh it on my computer here. Okay, we got 69 likes. I think that's actually enough. Nobody needs to hit the like button anymore because we're at a very nice place right now. But thumbs up in the chat are welcome. Alright. So it's time for PCBs. Something like this powers everything. I need to plug in all the stuff up there. This go in here? Oh, okay. Very clever. So this goes in here, it looks like. And then when you attach the fan to the front, it automatically plugs in these pins. Right here. Those guys. So pretty cool little feature there. That means I have to take out some of these screws that I used here and replace them with slightly longer ones. Yeah, I need longer screws for sure. Maybe button head cap screws. Okay, so we'll plug all these bad boys in. Hot end fan, part cooling fan. Okay, I think I know how to do this. Yeah, I'm smart. Yep, and just get that plugged in. Easy peasy. Alright, and that's that. Now I'm missing the cables for the hot end, the lights for the Voron, which I broke some of the cables, and I'm too lazy to fix it, so we're just going with it. And I don't feel like I need lights right now. Alright, so that will go on up there. And this gets plugged in somehow. Like this, or something. How does this go in here? Someone please explain what's going on there. What's the big idea? Do you have ads enabled? Probably. Gotta get that AdSense. Get that streamer money. Build the San Francisco seawall. Uh-oh. Hi, Zachary 3D Prints. Yum. Let me just send you some more sauce for your soup. Oh, Peck's Peppers. Yeah, Peck's Peppers has sent me some delicious hot sauce, which I recently started eating. It's very good. So everyone check out pexpeppers.com for the official source of hot sauce of Nathan Builds Robots. I do think this is spicy enough the way it is, though. It's muy picante, as they say. Muy picante. Okay, so what next? I think this gets plugged in over here somehow. I don't know how that works at all yet at the time. For the moment, I think this is like over here. Yeah, this looks like it goes right here. But how do you hold on to the PCB? Ah, there's 2 screws there. I see. So we'll just bolt this on right here. Does it need standoffs? Looks like it needs standoffs. Yeah. So, ooh, what kind of standoffs do you need there? This is getting confusing. It's making me angry. Okay, let's see. I'm confused now. I'm very confused. So, there's probably some never more specific documentation. Does anyone know what I need to look up? '80s telethon. Is that where people watch '80s TV as long as possible? Neil Munch, don't worry. If you have YouTube Premium, it pays me a portion of your like membership as it like just pays me out of that, like maybe 60% or whatever the typical AdSense is. It like divides up all the time that you spend watching content and then divvies out your whatever fraction of the monthly premium to people. Also, by the way, I disabled Bambu Lab ads on my channel when they decided to kick me out of their affiliate program. So I'd probably be making more off of AdSense with Bambu Lab ads, but it's a matter of principle. Those gaslighting suckers telling everyone, oh, we've never kicked anyone out of our affiliate program over people saying bad things about our brand. No. It's just a horse and pony show with all the content creators that are, you know, they're like, oh, look at these guys, these are the good boys. Yeah, they're critical of our designs to an extent. There's been a lot of stuff unfolding with regards to their new privacy stuff and all that. But now it's time to figure out how to install this onto here. So, time to figure that out. I assume there's a couple like standoffs or something, or a 3D printed part that spaces out this board from this extruder piece, because maybe this fits on just, no, it doesn't bolt directly on. It needs a little bit of a spacer. So I need to figure out what that spacing is and how to achieve it. Ooh-wee. Where is it? Yep, 6 hours. We're going for even more. We're taking as long as it takes to get the job done. I just need to figure out what I need to do. Well, let me show you guys. Maybe I can crowdsource the solution here. I'm trying to figure out how to attach this to the side here. You can see there's a 2-bolt pattern. You see those 2 bolts? I'm pretty sure those line up with these 2 holes, but the PCB won't go straight up against that. So, yeah. No, I mean, yeah. We could spend all day complaining about Bambu, but what's a better use of time is to spend all day complaining about other things. There's a PCB spacer. Okay. PCB, print out small cylinders as standoffs to the right height. Okay. Well, neither of those comments is helpful. So I'm going to ask you guys to step it up a little bit. Add a bit as spacer. Small cylinders as standoffs to the right height. Okay, so let me just plug this in and then see how far off it is. Huh. Let's see. I don't know what I'm doing. Okay. Okay, so it looks like those bolt holes do line up pretty good. It's just they're about 5 millimeters spaced off from the from the mounting holes. So they align, but they're not. There's not proper space there. So I need some 5 millimeter standoffs, or maybe some kind of model for that. Let's see. Okay, Peppers has sent me. I have that. I've seen that piece. Okay, he sent me a model. I need to find it now. That looks like this. So, I definitely have one of those. Maybe this? This kind of looks like it, but not exactly. Maybe there's another one. That's spicy stuff. Alright, here it is. Hex peppers. Coming in with the play. See, I was just kidding when I told you guys to step it up and that you're not doing good enough. But there was an element of truth to it. You guys did need to step up, and you did. So congratulations, especially to Pex Peppers, for being the real MVP. So, Jailstis Pro. Is there a heavy plate for the top to prevent racking? I don't see how the frame is robust enough to remain square. The XY stepper mounts can't possibly be enough. Let me think about that. Okay? I'm going to think about it for about 5 minutes while I install this thing, and then we'll go to the whiteboard and draw out a free body diagram and see what the racking forces are. But in the meantime, let's get this done. So we have the PCB spacer. Why on earth wouldn't they just build this into the design? I don't know. I have no idea. They have not told me what they were thinking. Alright. Oh man, that is annoying. Okay. But that's what we gotta do. At least we know what we're dealing with now. So I just need a little bit longer of a screw. I'm thinking these M3x8s. M3x6s might be a little short, so we'll try the 8s first. Yeah, these would be perfect. Maybe 3x10s even. We'll see how this goes. Yeah, I'm gonna go with the 3x10s if we have any. 3x10. Now, I will be flabbergasted if they don't have M3x10s in this kit. Because basically the entire Prusa design is based around M3x10 bolts. That's like the standard that they used. So basically every bolt on there is an M3x10 unless it needs to be longer. But maybe the Voron design guys had they bought a set of fasteners and all the M3x10s were used up by the Prusa when they put their Prusas together. So it's possible that they just don't have any in the design. Here's an M3x12, we're just going to go with this. And worst case, it's a little bit too long and we have to figure something out. Alright. Okay, we've got that up there. Get some bolts. Oh man. Oh, this is a lot easier to work with if you just take this off. Alright. Okay, too long. I think the M3x8s are fine. Come on! I'm shocked how long this tool head takes to put together. Not knowing what I'm doing is definitely adding some time, but I mean, like, if you look at something like the VZ bot, you're just bolting some things to a plate, or like most other designs that make sense. You just bolt a couple things to a plate and you're done. With this one, it's like this whole arduous process of getting all the pieces and lining everything up. And you can finally bolt everything together. Finally I bolted everything together. Brilliant. Okay, there we go. That's pretty cool though, because now this whole front piece doesn't have any wires you need to manage. You just slot it in the front and everything plugs in. So that's pretty sweet. I'll give them some credit there. That's pretty clever. Oh crap, okay. And this needs to go around the back. I keep forgetting that. This big cable needs to come around the back. Alright, and then this goes in here. Okay, and then we'll put this on the face. Oh no, these cables better be long enough or I'm going to be very sad. Alright, so those have to go around the back. Okay, this goes here. I have to line up the PCB, those pins. So when I press it on, everything's all wired up and we're in business. Okay. That was the most satisfying part of this build so far. Very satisfying. This pleases me. Okay, and our other bolts up in here. The bolts all over the place, so I don't remember which ones I need. Okay, where's the other freaking bolt of this one? Okay, I'm starting to see the value of the Revo hot end, like just thinking about it conceptually, being able to switch it out for a longer nozzle or a larger diameter nozzle on the fly. I don't think every printer needs one like that, but if it's a printer that you want to, like if you want to have one printer that can do multiple things, then, you know, for the most part run all your printers at 0.4, but when you want a bigger one, you can just switch this one up. Or if you have a gigantic printer like the Uri one or the Ender 5 that you install a larger nozzle on, that could make sense too. But being able to just run everything 0.4 standard and then being able to upsize it when you want to, that's pretty cool. Okay, so I need to find the other bolt that's this length. This whole process is not. I'm just gonna get a new one. Every once in a while, it's not worth finding the bolt that you lost. Just grab a new one out of the pile. And as long as you don't do that too often, you'll probably end up with enough bolts in the end. Let's go. Oh gosh, this isn't long enough, is it? Oh no, that's good. Very good. Alright, I have a feeling this is going to come together real quick now. Oh crap, these bolts are too long if anything, but oh well, that's fine. It's all good. Nice. Alright, let's take a look at what we've done. Ah yes, it'll only take you 10 minutes, bearded printer. Yes, very intelligent take. I think you should definitely give this a try, so you can prove your intelligence to everyone. Okay, that's plugged in. That's plugged in. Here we go. Yeah, I know this is like a real job, but I'm not getting paid enough. I'm getting paid, right now, I'm being paid $4 an hour. So it's not a great career choice to be doing this. I have to admit. I feel like maybe this isn't the best career move, but you never know. I did get a free printer out of the deal, so don't feel too bad for me. Okay. Screwdriver time. We just have to plug in those little heater wires. Alright, now we've got the Ender 5 working as a mobile camera jig. We need a screwdriver. Tiny screwdriver for the little terminals. I think we got it right here. Okay. And those are all wired up. And we give them we always want to give them a little pull. A little pull test to make sure they're installed correctly. That one wasn't installed correctly. Could you tell? It doesn't help that I can't see what I'm doing because of how tight everything is in there. Yeah, when you're doing professional electronics assembly and you know, specifying how to install everything, you'll usually want to do a pull test as part of the assembly procedure, just to make sure everything's sound. And what you saw there was what happens when everything isn't sound, and that could easily cause some major problems if you just go like that. So here's the little wire cover that goes up top. Gosh, what is with the order of operations here? Are they crazy? What the hell? What the? How was I supposed to know this was gonna need to be accessed here? And how? What? What in the freaking heck? Wow, no, oof. No. Okay, so I don't know what this cable is out back. Maybe it's LDO Nighthawk SB. I don't know what this cable does. This one right here. There's nothing plugged in there. I wonder if the stepper motor is supposed to be plugged in right there. I have the stepper motor plugged in down there, which might be the wrong spot. I don't know. See, stepper motor down there. Oh, 5-volt XY ground. Okay, yeah, that's not where the stepper motor goes for sure. We'll unplug that. So this isn't fully idiot-proof. You can plug in your stepper motor to the wrong cable, and stepper motors, for the most part, just act like a short circuit if you were to run current through them. So definitely want to get that right when you're doing this build. There we go. I assume that's where the stepper motor goes because there's no other spot for it. But yeah. All right. Let's go. Looks like we got some donations in the chat. Get yourself a coffee or pay your bills or whatever. I can't tell you what to do. All right, bearded printer. Very, very nice. Don't encourage me to... What do you mean don't encourage me? I need encouragement. Yes. Okay, so next up... what am I going to do? I guess I kind of want to put this wire cover on, but I think it requires me to take off the front of this fan thing. So that's a little annoying. Gotta unscrew this one more time. And I used the wrong size screws that have extra length, so I'll get those replaced with the right size when I put it back together. Come on, let's go. I wish there was a faster way to do this, though. You probably aren't going to be doing this all that often when you're actually running the printer. This is just an assembly thing that you might have to take this apart multiple times. Ta-da! Okay, unplug, move out of the way. Alright, now there's a screw that I can just back out. Oh, this is going to be hinged. That's awesome. Okay, so I'm just going to back this out. And then we tighten this screw in. Wow. That's cool. Okay. I'm liking this design the more it's put together. Actually building it is awful, and I wish that part was better. But once it's assembled, it's pretty cool. It is just a little fiddly to get into one piece. It's definitely making me wish I had a little electric screwdriver for this. Okay. Alright. Starting to think IKEA wrote the Voron assembly manual. You put the fan shroud on, you take the fan shroud off. Yep. It is, I mean, ideally you only have to put it on once, but when you don't know what you're doing, you actually end up having to put it on about, well, how many times has it been? Maybe 7 or 8 times? Definitely a skill issue, but it's one that I think is going to be pretty common for new users. Okay. Huh. Oh, I never tightened down the, oh. Huh. There's a lot of stuff I never tightened down all the way. Alright. Time to do up these screws. Couple more to do. And they're the tiny screws that I haven't seen. Huh. These ones? Yeah. And 3x16s. 3x16. I think that's what I need here. More of them. Oh yeah, that's nice. Ooh. Yeah. Okay. And we'll tighten up the linear rail that everything's riding on right now. Okay, those are all tightened up. Ooh, yeah, this is feeling good now. That's what we're talking about. Okay. And this doesn't really seem to want to fit all that comfortably, but that's what the screw's there for. Alright, I want to give you guys a little update on all this. Okay, there we go. Whew. Alright, so you know, here's what you can do to pop the extruder arm away so that it's not applying any tension to the filament. And you kind of push this up until it sticks, and then click that down. And its extreme clickiness is very satisfying. Also, all the cables have been hidden by this little guard in the back. Well, I guess there's a couple cables sticking out the back here, but I need to just tuck those away a little bit to get them out of here. Make everything a little bit neater. Yeah, I can tuck this little cable away, and then it'll just be this one wire coming out that powers the entire hot end through the little CAN bus cable. So that's pretty neat. And there you go. That's the hot end. And then I tightened everything up, and now this thing is feeling very stiff and nice. Look at that. All right, that's going to be great when that's running. Okay, so someone was asking about, what was the question? Someone was asking about the frame, like this whole assembly up top from here to here. So from here to here to there, and like, you know, basically with any Core XY printer, you have a whole frame. You can imagine this as being a big picture frame, that the plane that all the motion is in. And they were asking whether or not that needs to be stiff in order to have the printer produce good print quality. If you look at most Core XY printers, like especially this K2 Plus, it's got this massively thick frame up top. This is one single giant die-cast aluminum square that that carries all the load of the belt, like the belt tension and any forces that the motors are imparting on the printer. Same with this printer. This is the K2 Plus. Sorry. This is the Ender 5 Max. It's got a very solid frame here, pretty thick aluminum extrusion up front. That's a C-section, C-channel, with like a little bit of extra stuff down here. So it's like a semi-custom aluminum extrusion, but it's pretty thick. And then on the sides you have this plastic cover that's just decorational. I could take this plastic cover off. But underneath that, this whole arm, this whole right-hand side is a die-cast piece of aluminum. So that's extremely heavy duty. And then, you know, it's all bolted together such that you have a really rigid frame here as well. So the question is this going to be strong enough? Because it seems like the only thing holding this frame together are this corner piece, this bracket is all plastic. Same with over here, that's all plastic. And over here, that's plastic. And there's actually no beam across in plane there. But if you just look up a little bit, this is probably what they are using to close that structural framing there. So let's go to the whiteboard, and we'll talk about what's going on there, what the forces are from the belts. And I actually don't know the answer to this question, but we can figure it out pretty easily using the power of math, okay, and physics. All right, so you look at the printer from the top. That's a square. Everybody can see that's a square. Alright, this is what a normal Core XY printer looks like. You've got that, and then you've got a bunch of pulleys. You got one there, one back here as an idler, and then the printer, and then probably another idler. This is usually how they're set up. Alright, and then you've got some more idlers, which are mobile. So you've got an idler here, an idler here, an idler here, an idler here. And those are located on this middle frame. This is the X gantry that moves back and forth. And then you have the print head. And that's moving back and forth as well. I'm just putting a dot there for the center of gravity of those items. So the question is, like, how much load are these corners seeing? Because you can imagine if this joint wasn't rigid at all, like it was like a mechanical linkage where this was it had a pin joint and a ball bearing in there, and this could just slide open and close. How much force would be required for a motor to hold that in position? This is what we're trying to figure out by doing this analysis. So let's start by drawing in all the belts. So we've got a belt here. That's, you know, one of your belt loops. And then here's your other belt loop. I'll just draw these pulleys in green, just to kind of differentiate them a little bit. Although there are two, you know, there's two parallel belts that are running kind of along the same path for the most part. Oh, messed up there. That's blue. And you got this green belt running along. Huh. This isn't right. Huh. Man. These printers, they sure are complicated. Okay, so yeah, I drew this wrong. Yeah, because there's so many dang pulleys in here. Okay. It gets complicated. Okay. So this one goes back like that. And this one doesn't go all the way around. Green will come like that, bypass that, go through this loop, and go down up to where the tensioning occurs. So I'll change this to a green pulley. And over there. Okay, so basically, you know, you've got this, and just by tensioning the belts, you can imagine that's gonna impart some kind of load into the system, but it's all gonna cancel out. Actually, it won't. Okay, so there's a special type of analysis you can do where you basically just draw an imaginary line and draw a free body diagram around that portion of the frame that you're interested in. So I can draw an imaginary circle here and be like, okay, what's happening at this corner? Just looking at belts, you have a gap. I'll draw a little gap here. Just looking at belts, you have some amount of belt tension there, some amount of belt tension here, and then over here You got some amount of belt tension there and some amount of belt tension there. Now, for the green line, you've got a motor in between those two. So the motor might be doing something. You don't know. You don't know what's going on with this motor. So the motor's actually changing the tension between this point and that point. But for the blue belt, you know that the tension here is the same as the tension there, because all you have in between is a frictionless ball bearing. So the net force, I'm just going to simplify this into a single point. Hold on. I'm just going to simplify this whole purple segment into a single point. And you've got two equal and perpendicular forces from the blue belt. So we'll call this TB, we'll call this TB. And the net force there is basically these two added together. And we'll call this, this has a magnitude of square root of 2 TB at a 45-degree angle pointing inwards. So that's going to have a tendency to cause this to want to, you know, it's like wanting to open the frame up. So you can imagine if we get rid of this beam at the bottom, this whole thing would just want to open up like that. But this beam is here to kind of hold everything together. And then you've got some tension on the blue line. Now we're going to look at the green. We're going to do the same analysis, but just on the green. And you've got a pulley system in here where this tension should be equal to this tension. With one caveat, you've got a motor applying some torque in between that point and that point. So what that's going to do is it's going to, if we look at the pulley with the motors, you know, well, you can actually just ignore everything outside of the pulley and what's directly touching it. So the belt looks kind of like this. You know, because it's looping around that and then going around those two little idlers. You have two forces acting on this belt. We'll call this TG1 and TG2. And you have this motor, which is trying to rotate and apply some torque into the system that's coming directly from the stepper motor. So if the motor is off or, you know, not active at all, or it's moving at there's no acceleration being applied to the tool head, and there's actually some caveats there even with that case, then TG2 is going to be the same as TG1 because the motor's not going to be applying any torque. All right, so for zero torque, we have TG1 equal TG2. I'll write that a little bigger. Oh, geez. What have I done? Oh, no. All right, so in the case of zero torque, you have TG1 equal TG2, which is the same as the belt tension. Also, with that one, same thing, it's the same as the belt tension for when the printer isn't moving. Like, I like to do the analysis as if the printer isn't moving at all, because that makes things simpler. In reality, when both things are moving, it gets pretty complicated. But in reality, you can also write this as TG1 plus TG2 equals 0. But you can also, because we're considering the case for when there's 0 torque, but in reality, you'll have TG, I'm using T for tension and T for torque. It's going to get kind of confusing. So I'm going to use, I forget what the fancy math one is, but I'll use a squiggly top T. I think that's what they use for torque, tau. Like, you know, I mean, I could change this to F as well, and that would make more sense. But anyways, TG1 plus TG2 equals, I think we have to set one of these equal to negative. Okay, so hold on. I did some simplification here in my head without actually writing it down. So we actually want to do the sum of moments about this point. So writing this out, sum of moments equals 0 for the case of this being applying 0 torque. So we're going to have positive TG1 times the radius of the pulley. Times radius. All right, and then we have minus TG2 because it's acting in the negative direction. Times the radius. And that's set to 0. But in the case where we're not having 0 torque, then you actually have it set up like this. The torque from the motor, we're going to do tau m, is equal to TG1 times R minus TG2 times R. So what the motor is going to do is it's going to make it so that these aren't even. So another way to express this is divide everything by the radius of the pulley, and that gives you TG1 minus TG2, 1 minus TG2, and now we get the motor torque involved. You can look up how much torque a motor is just on its spec sheet. So basically, like a stepper motor will typically produce something like 60 Newton meters. We'll just say 60 Newton meters. Not Newton meters, usually it's 60 Newton millimeters. 60 newtons times millimeters divided by the radius, which on most 3D printers is about 6 millimeters. So 6 millimeters. So that is equal to 10 newtons. So essentially, the motor is applying a difference of 10 newtons to that whole thing. But really, I would say the pre-tension of the motor is probably still much greater than this. So this is kind of almost a negligible amount of force being applied to the system. So we can basically just ignore it. So let's just ignore it for now, unless you have some ultra powerful motors. Yeah. So basically, you're going to end up with a situation where we'll just ignore everything. The majority of the forces are just from tensioning the belts. So if we assume that both the belt tensions are equal and the motor torque isn't really applying that much force, then we can just add the green forces in here too. if we draw it in an additive way, then we just add it to TG, TG. So then we will add the green force there, square root of 2 TG. And we'll just assume that, that TG is about equal to TB is about equal to belt pre-tension. So, you know, you tighten up your belts and that's going to actually make this thing want to pop apart. But you've also got this, you know, this beam in the middle that's holding everything together as well. I don't think the frame being super stiff is a big factor. You know, I think the belt forces kind of cancel out in a way. They're gonna want to make this split open a little bit, but you've got this beam in the middle holding it together. And then you can start looking at it in terms of how much force is being applied to these, you know, laterally, because when you're accelerating the print head back and forth in the X direction, that'll make this want to, you know, bow in and out like that. And if we do a similar analysis to this, where we chop a chunk of this out, basically the only force you have is 2 times the belt tension pointing upwards, because you've got the belt looped around there. And that load is going to be directly carried by this beam here. There's basically always a beam there when you look at any Core XY printer. So that's kind of interesting. I think probably what's more interesting is what happens to this whole thing. This beam in the middle, the X gantry. Like when you tighten the belt, I assume what's going to happen is this blue belt is going to want to skew this and pull it so that the whole X-axis is running in this direction. Because you can imagine if you tensioned this blue belt loop up to infinity, it would want to twist like this so that it's forming a straight line between here and here. So the more you tension the blue, it's going to tilt the gantry like this. The more you tighten the green, it's going to tilt the gantry back. And that's why you want to balance the torque, or you want to balance the tension on your 2 belt loops so that it's not twisting the gantry this way or that way. And what's, like, if you just completely got rid of one of these belt loops, let's say, you know, you don't have an equal and balanced system, and let's say you you just got rid of this green belt loop and replaced it with a second motor over here, or just a motor on here, which is like kind of this hybrid belt system that some printers will use. Then the belt tension from the blue loop is going to want to, you know, twist it like this, but you're just going to have to make this joint strong enough to resist that desire to bend it. Kind of interesting stuff, but at the end of the day, I don't think you get that much force from these. I mean, you have the belt tension times a little bit, but you know, this is gonna, you know, it's gonna want to open up like this, but this is keeping that from happening. This beam and this beam are going to be really effective in preventing it from like actually splaying out. So yeah, and long story short, you don't really need that strong of joints up here. I mean, you could try printing that out of TPU and see what happens, but I don't think it would be that big of a deal. All right, any questions? Any questions from the chat? Do we need to do some more 3D printer analysis, or are we good here? We're looking at how that force is flexing the frame at the back corner is offset by the tensioning torque, keeps the front pulley in, and how it keeps the gantry square. Yeah. But as long as both of the belts are tensioned equally, I think everything pretty much cancels out. And any kind of force that's going to try and split this, straighten everything out, this beam and this beam are going to prevent it from happening. The only one that I'd be really concerned about is these plastic pieces, because when you tighten it, it's going to want to try and twist the gantry. But if you have an equal and opposite one on the other side, then that's going to keep it straight, because they're both just going to cancel each other out. That's pretty interesting. I don't see a lot of people doing this type of analysis. This is the type of engineering analysis you do in college, in a mechanical engineering degree. But at the end of the day, what ends up counting is the practical implications of it. Like, you can do all the analysis you want on this, but you end up finding out that there's some other physics at play that you're not looking at all that ends up being way more important. And that's why overbuilding everything tends to work out, because there's forces that you don't anticipate, like vibration forces and other type of things that just get completely squashed and ignored because you make everything strong enough. Despite, I could do some analysis here and end up discovering that all I need is a tiny little bracket there to hold everything together. All right, so that's about it for that. Let's go back to building printers. All right, I'll let you see this just so you can. Oh, jeez. Uh-oh. I fell over a little bit there, but we're all good. Okay. That may or may not be on the midterm, so I want you to take your notes with you. All right, so where were we in the Voron build? Ta-da! Oh, nice shirt. Thank you. Someone finally noticed. This is my custom shirt that I printed in Japan. Look at that. Look at that cutie. I went to Nara, where you get to pet the deer. It was very fun. Okay, anyways, back to printing and setting up this printer. We just need to plug everything in, and I think we're good to go. So it's time to look at the electronics assembly part. So if the belts are in equal tension, that prevents the print from going rhomboid? Yes, it should. Or it'll prevent there from being any net force, and it'll be as rhomboid as it was when it was assembled. Or the minor gussets of the motor mounts are more than enough for that? Yeah, so because you have an entire frame, and there's no net force trying to rhomboid anything out, it ends up, they don't end up needing to be very strong. They're probably quite strong in tension and compression. Like if you were to try and pull those apart or push them, force them together, they'd be very strong, but they're probably not very strong in terms of getting skewed. But having more structure there is never going to cause you issues, so I would still want to design it to be as stiff as possible if I was just building something from scratch. I really want to take a look at the Core 1 when I get that in, because they use a large aluminum plate to hold everything together. Okay, and then next thing up, if you look at the Core XY stage on this type of 2.4 looking thing, it's actually extremely wimpy. Like, look, there's no beam up front holding it together. And it goes skewed all the time. Like, if one of these belts goes up a little bit more, the whole thing is able to flex and account for all that. So I don't think the stiffness of the corners really matters all that much. Like, you can imagine it's if it wanted to bend, that's not actually very strong over there. Because if you had some force trying to open that up over this extremely long distance, like, it'd be pretty easy to do. But yeah, you just assemble everything square and make sure you want to just assemble everything square and make sure the belts are the same tension. And that should make sure that everything tends to stay square when you're printing. And it's easy to say that in hindsight, but I doubt that would have been obvious just from looking at things, before you actually build things and try it out. Okay, time for wiring diagram madness. Wiring diagrams. Where would we be without wiring diagrams? Okay. Here we go. Okay, so I'm looking at I really should be looking at the Nighthawk specific wiring, but I'm not going to. I think it's going to be pretty obvious what we need to do just by looking at things. Alright. There's some little bits of plastic that I need to use for cable management. Just going to try and find those. Here's a little interesting experiment we can do. If I pull on one of these belts to increase the tension, we can validate our hypothesis. Look, I'm just taking one of the belts and yanking on it to pull on it. And let's see, I'll hold this still so you can see what happens. You see it's trying to pull this thing out of square. So let me actually set this on the frame. We'll get some reference points so you can kind of see it for yourself. But okay, so right now I have this belt lined up with the back edge of the bed, so you can see they're pretty much perpendicular. I mean, yeah, they're pretty much parallel to each other. And when I take just one of the belts and pull on it, what's moving more, the left side or the right side? It's hard to see because, we've got the... But I'm going to pull on it again. Tell me if the left side or the right side is moving more. I'll move this back a little more. What's moving more? Come on, guys, you can tell me. So if the right side is staying stationary and the left side is being pulled back, that's definitely pulling it out of square. All right, now let me pull the other belt. So I'm just switching which belt I'm pulling on the back of the printer. Now which one's moving more? The left side or the right side? See, when I pull the other belt, it's moving the right side more. So that's being pulled out of square in the other direction. Let me switch again. So you can see how getting the belt tension equal is important. But now watch what happens when I pull both the belts at the same time. I'm going to pull on both of them. Both sides are moving back a little bit. but the overall squareness is remaining the same. Ah, okay. Yeah, your left and right might be reversed, but you see what I mean? So as long as the belt tensions are equal, the whole thing should stay relatively square. Happy printer noises. Okay? But also, it's interesting to think, I mean, I'm getting too into the weeds now, but it's also interesting to think that rapid accelerations when the print head is over here is going to be different than rapid accelerations when the print head is over there. So, like, if you wanted to do more calibration for input shaping, like the input shaper would be more or less sensitive on this side of the print bed as it is on this side of the print bed, depending on which motor is applying more torque. Premier Creality channel building Voron? What? Don't worry, I'm taking every opportunity I can to turn this into a Creality commercial. The camera's still mirrored? No? Can you read this? Okay. I don't know if you can read it or not, but we're going to keep going. All right, now it's time to do wiring, which everybody knows is the most fun part of anything involving electronics. Let me pull up my my live feed. Okay, so now you can see the electronics here. I'm not sure if this is the best view. Here, maybe if I move the motors up. Yeah, I'll move this upwards. It's going to give me more space to work with for the electronics too. So I want to move this up as high as I can. Can I do sensorless homing? Because I would really like to do sensorless homing. I want to wire up as little stuff as possible. Whoa. Whoa, interesting. Yo. Am I doing my belting right here? It's hold on, let me reverse. Here we go. It looks like this is like carrying a lot of tension when I'm trying to move the belt up to the top. Like it's preventing me from moving that up any further. Did I use the wrong belt length for this, or do I need to install some of these extra links or something? Or did I put this in the wrong spot? Oh no, I'm using up all the memory. I'm destroying your computer slowly and using it to mine crypto. Alright, so what's the deal with this? Why is this so tight? Did I use the wrong belt? It's looking like I might have used the wrong belt. But they also gave me a couple extra links of belt that I can probably throw in there. I will find them. There's some belts around here somewhere. I swear I have some belt links around here somewhere. I just have to find them. So give me a minute. And I can make that belt a little longer. Oh, here it is. Yes, randomly on the floor. Okay, so I've got a couple extra belt links here. I'm just gonna, I think, just pop these in that spot, and that'll give me the extra length I need. So let me just open these up. These have a little little clip spot. You can just that didn't work well. Oh man, I'm mangling those. Okay, that's the wrong side. Whoops. Okay, right here. Just flip these open one at a time. Okay, and then we need to add these over here. Okay. All right, there we go. 1, 2, 3, 4. Come on, last one. 4. There we go. Okay, now we've got enough belt length to go all the way to the top. That's what we need. I wonder if that's what those extra lengths of belt were for, because now that fits perfectly. You can see the cable chain goes all the way up to the top and stops perfectly where it needs to. Ta-da! Okay. Now time to get all those wires wired. That is the best thing to do with wires, is to wire them. So we're gonna flip around like so and see how all this gets plugged in. So, all right, this cable. There's clearly some sort of extension cable that this gets plugged into that's not here right now, and I guess I can pull all the slack here down into the base of the machine, because this is about as much as we're gonna need in terms of cable length. What is the best way to route this? I feel like I should just cut this shorter, these ones shorter. Okay. Because the yellow one needs to be longer. Shoot, I don't want to cut wires. Who am I kidding? Let's plug those back in. I'll just bundle these up with a zip tie. This one, on the other hand, I need a little extension cable for, so I'm going to check my cable thingy. And we'll find it. Okay, I think I got it. Okay, I've got these two. This is a bed thermistor. Huh? This can't plug into this. Filter fan. Really, I feel like this one looks like the bed thermistor extension cord because I need something that plugs in here. Right? Yeah. Kind of like that, but because this is a male JST connector, and that doesn't work with that. Unless there's some kind of little breakout board up here that I'm not seeing. You know what? There's probably a little breakout board up there that I'm not seeing. And or haven't installed. Because of reasons. Okay. Okay, so I've got these. I'm guessing maybe it's this one, although this one doesn't have any labeling on it. I think this is actually a fan splitter. So I'll keep looking. Here we go. This looks like something that might be what I need because it plugs in. I can just plug one end in here and then plug the other end of that cable in, and then there's like a little This probably goes into some kind of 3D printed housing though, to keep it from shorting against anything. I'm not sure what to do here. It's time to read the instructions. I didn't want it to, I really didn't want it to get to this, but I think we're at that stage where we gotta read the instructions. Hold on. I think I see something. No, this isn't it. This is the Z end stop, which gets installed somewhere. Okay. So I know when one end of this bed thermistor thing gets plugged into. Just plug that portion of it in now. We know this goes probably into one of these thermistor ports. It's one of these. All right, let's see. All right. I'm gonna have you guys look at the glorious whatever this thing is. Okay. You get to watch the Uri1 printer while I find the instructions that I need. Okay, so I have to find a couple things here. I have found one of the things. Rest assured, I will find the others. Okay, found one thing. Wouldn't that be something? Alright. I might have to use a modder board here. I do have modder boards that could definitely be used for this purpose. So, you know what? I'm going to do it. What's a modder board, you might be asking? Well, that's my the PCB that I produce. That's used specifically for modifying Ender 3 S1s. Let me just find one so I can show you what it's all about. Okay, so this is one that a customer sent back to me because according to them it was defective. Now I won't show their name because I don't want everyone to know who they are. However, I have a feeling that there was nothing wrong with the board and they just returned it because they didn't know what was going on. I issued a replacement for them. It was no big deal like that. But I asked them to send it back just so that I could test it and make sure there's nothing wrong with it. So yeah, I don't think there was anything wrong with it, but I sent him a new one and I think he was happy with it after that. Two of these pins are shorted together, the PF1 and PF2 slot. So I'm just going to plug in both ends of that adapter into this, and I'll just have this hanging off the bottom of the printer. And yeah, there doesn't appear to be any faults on this board. It's a very simple design. And the only thing that could really happen here is if some of these traces were to accidentally bridge together or not have continuity, like they don't get soldered down correctly when they're manufactured. But everything here looks pretty good, and I do test 100% of these with my Mr. Clicky apparatus. So we're just going to bolt this to the bottom of the printer and use this as as the PCB coupler. So that'll be fun. Now the question is, do I want to cut everything back to make this as narrow as possible, or do I just want to stick this on the bottom and use it like that? Because like I could cut off like the whole bottom half of the board, since that isn't really necessary. This is like a drop-in replacement for the stock breakout board that Creality ships with the Ender 3s. But so that's why it's like this specific shape. But I only need this top portion. I think we're just gonna have it hanging off the bottom here, like so. Maybe like this. Yeah, that'll work. Okay. I just need to. I'm just gonna break these little couplers off. I don't need those. So here we go with the clippers. Now don't try this at home. I'm what you'd call a professional. Oh crap, I just dropped some stuff into the power supply. I think I got it. Okay, so I just pulled off those traces so they're not going to be in the way anymore. Then I'm going to put some tape over that so that I can just bolt this to the bottom here, and I'll have a couple extra PCB plugs to plug everything into. And these are using standard JST connectors. They're really common hardware. You're saying I have a diaper. That's funny, because it's true. The stream stops for no man. No number 1 or number 2 is allowed. Alright, so we'll plug one in there. Now this isn't a recommended usage of a motherboard, but, you know, I know what I'm doing. I know my rights. And we're just gonna go like this. So typically the part fan 1 and part fan 2 ports they're just basically shorted together. So the positive of this one is the same as the positive of that one. And this kind of just acts as a pass-through. So we've got that hooked up, and I'm just going to bolt this up here using some of these screws that are right here. Now, an interesting thing about these type of nuts, you know, these nuts right here, I don't know if you've seen these before, but these are the type of like self-retaining T-slot nuts. They actually don't work in V-slot. They only work in T-slot, because V-slot has like a slightly different geometry, and these require like very specific geometry to work. So I've bought these before and tried to install them into my Ender 3s, but since they're using all V-slot, it didn't work out, and I thought, you know, I got the wrong parts. But after messing around with these enough and kind of figuring out how these nuts, you know, these nuts with the little balls work, I've discovered that it's really designed to only work in T-slot. So there you have it. All right, now I'm going to get some dielectric tape. I'm going to use Teflon tape for this application just because it's like super thick and abrasion resistant and insulative, and those are all things that we want. So we'll just tape that up right here. Ah, crap. I'll just cut that off and then we'll stick it up there. If you want to check out a motherboard for your Ender 3 S1s, they're in the description. If you go to my website or my store, whatever it's labeled under there, you can pick one up. I'm not the best at shipping things on time, so I apologize in advance. But every order that I get, I do ship out. So just take comfort in the fact that I take it seriously. Okay, so now we just have to poke a hole in this for the screw to go through. Then we can bolt this to the bottom. Okay, and then we'll poke another hole through the second one. Okay, I think I need to let this go a little bit further. I hope I'm not pushing this too far. I pushed it too far. Okay. We'll get this eventually. Okay, let's see. Where'd my little Allen wrench go that I need? This one. So we'll loosen this up, and crap. Okay. So we just need to line it up so that this hole is lined up with the hole in the tape. Okay, well, we'll get another shot at this. I'll put this one on. So this Teflon tape is what's pretty commonly used in like heat sealing machines. So like vacuum, like if you have like a food preservation thing and it pulls a vacuum and then heats up the plastic to melt it. But you don't want your tool to stick to the plastic bags when they're melted, so that's why they use Teflon. And it's got some kind of fiber reinforcement too. Pretty cool tape. Some of my favorite stuff. All right, there we go. That's good. All right, so then we just have to run these little wires through the cable chain, which I don't know how we're gonna do, because I mean it really wasn't. Wait, hold on. Bed? Okay, yeah, this is all good. This is good stuff. We just need to run this through that cable chain at the back of the printer now. Which there's not going to be an easy way to do, but since when was building a Voron about things being easy? I don't think it ever was. I'm going to twist this cable, so I'm just like, twisting it so that the cable behaves a little bit better when I'm trying to run it through to do the things I need to do. And see it kind of becoming more concentrated and twisty here. And now we're going to run it into that cable chain. And my gosh, this is going to be difficult. I think I'm going to have to... I couldn't find it, alright? I couldn't find the PCB or the little thing that it was supposed to get bolted to. So this is where we're at. On the plus side, I've now got a bunch of extra ports down here in case I need to plug more things in. Okay, here we go. Now begins the yes, product placement. What's the best angle for you to enjoy watching me struggle to put this cable down through the cable chain? Okay, here goes. Alright, I'm gonna do something drastic here. It's actually time to clean off my desk, so everything's going in the bin. Was there a PCB there? I don't know. How many people have bought a Voron kit but never put it together? If you had to guess, like, percentage-wise of all the Voron kits that are bought. I have no idea where these parts go. I have a feeling that I just got a bunch of extra parts for no reason, and I'm convinced that I'll never need them, so they're just all going in this area. Alright, so now I'm going to do the brilliant move, 1000 IQ play here, of turning the printer around so it's easier to access the part that I need. Alright, now you can see I have full access to the cable chain. So here goes. You think the Voron V0 is more difficult than this to build. Alright. I have a hard time believing it, but for the sake of argument, let's say you're right. It's also smaller though. It's so much smaller, so like, isn't there less annoying stuff to do? Most likely. Holy moly. So why did Soval copy the SVO8 instead of the Voron Trident? I mean, copy the 2.4 to make the SVO8 instead of the Voron Trident, because they could have just copied the Voron Trident. Probably would have been way easier. Okay, I'm going to open all these up. 2.4 is better than the Trident. Wow, okay, chill guy. You're really going to say that to someone who's been spending the last 8 hours of his life putting a Trident together? You're a nice guy. I can tell. Alright, we'll open all these up. 2.4 is more popular. Trident is less finicky build. Okay. 2.4 allows. I guess that's true as well. Alright, we're putting all our cables away. There we go. also shove this down the rest of the way and get it into the bottom chamber. I can't believe that this has taken 8 hours to get this far. Alright, I'm going to get caught up with the chat after I get this wire pulled. There we go. Da, 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 da. So, of all the people that finish building their Voron, Lost in Tech's talking about the SV08 Mini, which I took a look at FormNext. It looked pretty cool. I think the price point that he said seemed a little high for what it is. It looks fun, though, for sure. Alright, we got this down here. I'll plug this into one of the thermistor ports. Alright, and then we've got our bed heater stuff all wired up to this. Alright, this is the most overkill thing I've seen in a while. I've got this little bed heater, right? This little bed. It's not very large, but it's, what's that say? 120 volt. So this is run off of the mains power using one of these solid state relays. So I'm pretty sure they did that because for some people they like, you know, if you have a larger printer, you need that extra voltage or power delivery. But for me, I've got a 250 bed on here. I don't think it needs 120 volts. That's what we've got. All right, that's what we're dealing with. All right, we're going to close up all those cable chains. Nice and beautiful little cable chain with all our special little cables in there. Ah, that's the stuff. Okay, what next? I think everything's plugged in. I just need to find a place to secure this, this stealth burner tiny breakout board. So basically you plug in the power and the CAN bus on here, or maybe it's just USB Type-C. And then that sends the signal all the way up to the CAN bus up top, up there, through this thick cable. So instead of having to run about 8 different wires up there because you need positive and negative for your hot end fan, your cooling fan, your hot end for the heating element, and the thermistor, as well as 4 wires for the stepper motor, and then probably another 3 wires for the bed leveling sensor. Instead of having those 12 plus wires, you simplify it down to just one cable that has 4 wires in it. Delivers power and signal using 2 pairs of wires. Very cool stuff, very cool. Yes, better. It's because I have to run my fingers through it as a stress relief. And it combs it down over time. Okay, so I'm going to catch up with the chat. We've been through a lot together so far. 2 threaded inserts right next to the Wagos where the little PCB... Oh, are you kidding me? Oh, wow. Yeah, that could have saved at least 5 minutes of my time. Well, I might as well put the PCB there so it doesn't get lost. Does anyone know where that PCB went? You know what? I'm gonna crowdsource this. Here. Someone tell me where the tell me where the PCB went while I read the chat. It's in there somewhere. Okay, yes, it was great product placement, and it's going to be there for the rest of the time. What do you use that roll of PTFE tape for? I don't know, really. I just buy a lot of things that I don't end up using. Some would say I'm a hoarder, but others would say that I'm just prepared. I'd be a liar if I've said I've never done that. Tape a piece of filament to the end so you can pull it through. That's smart. That's really smart. So you just run the filament through and then use it to snake the wire through it. Okay. Oh, you're my favorite YouTuber, Lost in Tech. Someone ban the chill guy. That is unacceptable in here. Unacceptable. So, Trunksy 5X, I'm going to look that up. Trunksy 5XSA? 5SA? I'm seeing, oh, okay, 15% off. I'll use that. So you can get 15% off, $13.84. By my math, that ends up, oh, 16% off. Wow, that's a 1% extra. Amazing. Okay. Anyways, so 16% off of $384. That's going to be about $340. Maybe $330 or so. What was chat saying? Chat was saying $260. I mean, not quite, but pretty close. So I don't really work with Tronxy anymore because I made a long video that took a lot of time and resources. I'll show you the video. Hold on, let me pull it up on my computer. Okay. So I did a video on the Tronxy Crux. Here, we'll take a look. Is this upside down? You're upside down, sorry. Okay. I did a video on the Tronxy Crux. Okay, that was fine. It didn't have the best print quality, and you can see that if you watch the video. But then I was like, hey, I really want to see what I can do with your ceramic printer. That looks really fun. So let me find that one. See where it is. Yes, this one. Printing with clay. So this was the Tronxy More 1. It made a huge mess. It took a lot of extra equipment. I had to buy a new microwave just to use with this thing because I didn't want to frickin' contaminate my microwave. And God, what an amazing haircut I had back then. You guys make fun of my hair now. He should have... You're missing out on prime hair, Nathan. Okay, so it made a huge mess. I used a ton of expertise that I have in working with clay because I've actually spent years in a ceramics studio doing clay stuff. I really like ceramics, and it's one of the inspirations that I have when I work on my 3D printing projects. Because, you know, it's like a type of additive manufacturing. You start with nothing, you start laying clay down, and you get your whole thing there. Hold on. Let me flip this around. I'm sorry, guys. I know you hate the words thing. I made this video. It took forever. And then I tried talking to some local artists, and they're like, I don't really believe in machine-made art. So, like, everyone's being all snobby about it. Anyways, I spent probably 100 hours doing this. And then they dropped their affiliate rate to 1%. I think it was actually 0.75%. They changed their affiliate rate after I did all that work. So at that point, I'm like, okay, screw Tronxy. They're going to seriously give me like $2 for every one of these that they sell after I spent so much time working on it. So I think No, yeah, I still have my referral code there. But it's just insane. Like, yeah. Anyways, it was a fun printer to use. Like, I do like the process, but it's quite finicky, and I think you have to have basically expertise in 3D printing as well as expertise in working with clay to really get the most out of it. So it's really not for everyone. It is really cool, though, and I like it. I think it's cool tech. So that's the story of Tronxy. I think it was like 2 or 5%. I wasn't really in the know of what I should be looking for back then in terms of affiliate or like trying to make money off of my channel. Like nowadays I always think about like, okay, what's the profit driver if I'm to make content about this or that. And if there's no way that I'm going to make money off of something, I can do it just for my own entertainment, or I can run an external sponsor on it, or I can ask them directly for a sponsorship. So I've always got to be thinking about how I pay for all this stuff, because you know, this whole office I'm renting just for the YouTube channel. And you know, other expenses, cameras, equipment, that kind of stuff. I mean, it is pretty much a full-time job to be doing this kind of thing. Anyways, let's get back to the printer. Oh wait, no, catching up with chat. I'm curious what else you guys are talking about. Yes, I have a diaper astronaut style. This is gonna be something that hits the heat certs next to the Legos. Ah, okay. Did anyone find the? Did anyone find the? Oh gosh, are you still upside down? I think you're fine. All right. Sorry, I thought you were upside down, so I flipped it. PCB is just a JST splitter. Yeah, we didn't see anything in there. My crowdsourcing didn't work, so I will dig through and find it. Here we go. All right, this thing. I'm just going to install it where you guys told me to install it, because otherwise it's just going to get lost somewhere and never used for anything. But at least if I put it in over here, it'll get, it'll be in a specific spot, but it'll never be used for anything. But that's better than being lost. Okay, so that goes in over here. Ah. Oh. Crap. Why is this so difficult? Anyways, if you guys are interested in more rants on the creator economy, I can get into it, but it's interesting. I mean, for me it's very interesting. For you it might not be interesting. Okay, so there's that. I'll put in some I think there's an upper piece to this PCB holder, so I'm going to try and find that real quick. Although I'm pretty sure I lost it. I've looked for it several times. No luck so far. Oh, no, here it is. Wow. Amazing. Okay, this one looks like it uses slightly longer bolts. We're going to use the M12s, M3x12s. Let's see if that's the right length. That looks about right. These white pieces were printed on the Creality K1C. I mean, if you want to hear my thoughts about that printer, it's not great. I think the heat break that they were using isn't amazingly designed. So it lets a little bit too much heat through and you can get heat creep. But the bigger problem, I guess, for me was that I was using it while traveling and dust got on the filament, which caused it to get a clog. So I think it was the dust that was the main issue. And that caused a jam, which caused there to be filament just sitting in the thing for hours and hours at temperature. And that caused heat break, which then meant I needed to replace the nozzle because it got really clogged and melted in there. So yeah, basically that's when I did my rant on why you need to use clean filament and keep the dust off of your filament, because it really wrecks your printers if you use dusty filament. Okay, that was actually something, I don't know if Polymorph is still in the chat, but Polymorph was complaining about how the dust where he prints causes his printers to not work, and I'm like, oh, you know, maybe there is something to that. Okay, now where does this go? I have no idea where this is supposed to go. This probably tells me somewhere. Like, does it... It's not obvious what to do with it. Maybe I'll just zip tie it somewhere. Feeling like zip tying. We're at that stage. Hey. The zip ties aren't fitting through here. Come on. Okay. Come on. Why? Did you install the Wago mount upside down on purpose? No, I didn't. Is it upside down? I don't know. I mean, it doesn't... Don't you want to be able to open those up like that? Invert the inverted electronics? No. I'm not doing that. Okay, 100%. A lot of the great success Bambu ecosystem is the lid on the AMS. Yeah. I mean, talk about a feature that went underappreciated, unrecognized by everyone. But you put a lid on your filament, and that's going to greatly improve the reliability of your printers. Just because you're keeping the dust off of it. And even though nobody realizes that, you know, you get increased reliability from doing something like this, it for sure saved like thousands of people from having clogged nozzles, which definitely like gives people the perception that your printers are more reliable, because they legitimately are. But there's no magic secret to it. It's just keep your filament clean. All right, so let me, I'm gonna have to drill out one of those things. Going insane, maybe? No, I'm fine. I'm fine. Everything's cool. We're having a great time still, right? Alright, so I just need a screwdriver. Maybe something like this to broach out that hole. Let's go. Putting a spool in their chamber is a great way too if your printer has room. Then you get passive drying. Yeah, I like spool in the chamber. That's a decent idea. The issue is that you have to reach around a hot environment. So you might get burned by the heated bed or the hot end when you're messing around in there. So I personally don't like that as a solution nearly as much as just having like an AMS type of thing going on, but it will help as well. Okay, we're gonna zip tie this puppy down. Okay, pulling the zip tie through. I have no idea where this is supposed to get bolted down normally, so we're just doing the good old zip tie approach. Okay, big brain time. I'm going to rotate this around so I don't have to reach so far into the printer to work on this. Okay, that's good. Now we'll plug this in over here. And boom. Oh yeah, this got kind of mangled when I was force feeding it through the cable chain. I think it'll be alright. Just going to straighten the pins out a little bit. Ta-da! Okay. And Clipper time. And we'll plug in the USB. Oh man, this thing is, I can already tell, this thing is going to be a nightmare to actually set up and configure and make sure everything's talking to each other. Between the random bits of it that aren't completely stock to the things that I decided to do different, to it being a Klipper machine that's got all sorts of weird stuff going on, and the CAN bus tool head and all that good stuff. It's just gonna be a lovely time. Okay. And I probably want to clean up the cable management a little bit here. We're just going to use zip ties to tidy everything up. Anything more than that is just being an overachiever. We don't go for that on this channel. Okay, so we've got plenty of room, and we've got plenty of zip ties, and we're just going to go ham. Now, I think you're supposed to use the provided little cable tray things. These things, this is what you're supposed to use, but I'm just going to use zip ties because okay, I'll use these things for a little bit. I don't know. I'm having a hard time deciding. I should probably use these a little bit in combination with some other stuff. That'll be the... I'll do what I can with these, and then the rest I'll do with zip ties. How about that? Deal? Deal. So I'll use the zip ties to hold these cable trays down. And use slightly bigger zip ties for the job. You always want to use as big a zip ties as you can fit into any application. So I'll just get that in here. Alright, I want to give you some up-close action. All of the loyal viewers who have been watching this whole time, you deserve close-ups of all the fun stuff that's happening now. This is the big payoff that we were waiting for. So here we go. Okay. Nope. There. All right. You see that? Let me see. We'll get the live. Make sure we're live on my monitor. Okay. Here we go. That's a pretty good view. Okay, now we'll fit this. Oh wow, I just moved my phone around on top of this thing and completely forgot that I might have done some real damage there. But, alright, we're gonna get this over here. See what I'm doing? I'm just using the zip ties through these little holes. And hold on, let me get these cables out of the way a little bit so you can see. I'm just doing the zip ties through these little holes, wrapped around like this, back down through those little holes. And that will hold them in place. Just about. Alright, so we're using a little bit of this cable tray stuff. This is pretty typical to use in like professional electronics. We don't really like to call ourselves professional here on this channel, but if I can find a way to use zip ties and still be slightly professional, then we're going to do it. Alright, so there's that. Mostly we're just going to use this as a way to bundle up extra cables and get them out of the way as much as possible. Alright, so we can pop in over here, have this go inside of the cable chain, and pop out over here, and that covers up most of the stuff. Okay, and this doesn't have a whole lot of slack, so maybe we'll just stuff it down there. Down there, just to keep it kind of anchored down at the bottom. We've got quite a long stepper cable here. We don't need all of this length, so what we're going to do is tuck this away as much as possible and then have it enter into this little cable tray. I'll weave it through some of these little thingies just to kind of get it to lock in. Run it down over there, make a U-turn, go back and forth a couple of times to eat up the extra length of this. Okay, I'll call it good over there, and boom. Wow, this is looking neat. Alright, and then this we will feed in through there. Run along that, feed back into the channel, loop around, come back, and pop out right over there, right next to the solid state relay. So there's, not much. I'm having fun, if you can't tell. This is what I like to do. This is a very joyous occasion for me. Okay, definitely not, yeah. Okay, now, next up, we will manage another cable. this long stepper motor cable run. Now I'm not actually using these properly, so don't use this as an instructional video for how to be a pro electrician. But this is the way that I like to use them because it requires less thinking. And I've already had to think about this problem too much. So we're done. We're done with that. Okay, now time to waste some of this cable by running it back and forth and back and forth. Here we go. Amazing. All right, are you guys able to see what's going on here? Hopefully I haven't been hogging all the good views of this delicious wiring process. NBR is a comedy account. He's protected by parody. Oh no, I'm just humming the Jurassic Park theme. It's not copyrighted, is it? I found it on printables. Here, let's see, does this get a better view? I'm curious if we can see more of the cables this way. Oh yeah, that's nice. All right, feast your eyes on the cable management process. Look at all this. Yes. Mm-hmm. All right, and we'll come out over here and plug in right there. We'll eat up a little bit more of that cable length, and delicious. Deliciously efficient cable management. We can actually go a little bit further, pop out there, go back in, come out over here. Wow. Ah, yes. LARPing as a cable management, electronics installation technician is quite fun. And if you want to do that, I think a Voron kit is the perfect way to get started. Oh man, there's so many cables here. Okay, we'll tamp that down. All right, both of these, I guess, can be zip tied together and managed neatly that way. So I gotta find my pile of zip ties. Oops. Oh gosh. Upside down? No, here we go. There we go. Is that the view we've all been waiting for? I think so. Okay. Alright, so for these little guys, I'm going to zip tie this together. We'll just bundle these cables because they're basically doing the same thing. Just oh wait, this has a 24 volt rail, does it? No. Yeah, this is only 24 volts. I thought it might have a 48 volt rail, but it doesn't. Check out my G-Shock. Hell yeah. Watch time. Man stuff. I just got into watches last year, by the way. And I've been having too much fun with it. Alright, there we go. Ta-da. HV, what? It says HV. Okay, so if you do have a 48 volt stepper, if you do have a 48 volt system, you can use this HV cable and plug that in so that you can get 48 volt stepper drivers powering your Core XY stage. But I'm not going to do that. I do have an extra power supply laying around though, so if I feel like doing some crazy stuff with this build, then I might bust that out. But for now, I'm just gonna be a normie. Okay, stuff that in there, stuff that in there. Go over here. Go down through there. Nobody's gonna notice that. Someone might notice, but we're just gonna ignore them for being haters. Okay. Alright. Up through there. Pull a little more slack through the system. Okay. I'm gonna get a couple zip ties to hold this cable down for now until we find a more permanent solution. Not sure what to do with these cables, these guys. There doesn't seem to be a super neat way to deal with them, so for now I'm just gonna run them. Well, I guess I could run this one over here. Yeah, there's enough cable length to have this one switch sides, come along the back to over here, go down through this. Pop up through here, go through the cable trough a couple times. And alright, and then we'll plug that in over there. Just gotta make sure I have enough cable around there. Okay. All right. Yeah, I need more cable. Okay. Full time. For those of you that are still watching, you do realize this is on a loop, right? Oh wow, you have the worst view of all time. My apologies. Okay. So I don't know how exactly I'm supposed to run these cables, but that's how we're doing it for now. And this Ethernet cable is looking mighty sloppy. We're just gonna take all the excess there and bundle it up and zip tie it. Alright, the nice thing about this printer, it should be nice and quiet because of the fanless power supply. And LDO tends to provide pretty good quality fans, I assume. And the motors should be nice and quiet. The frame's pretty stiff, so there shouldn't be a lot of resonance. I'm looking forward to this. Yes, gotta love the temporary solutions that end up being permanent once you finish the project. It happens all the time. Okay, time to cut off all these zip ties. All right, we're looking good. We're looking mighty fine. Oh yeah, that's nice. We got one last cable here that's looking a little too long. I'll just bring it in over here. Do a couple loop-de-loops. Okay. Okay. Wow, that's looking great. If I do say so myself, look at that. Hold on, let me turn this around. Yeah, that's good. That's nice. Okay. No, I'm not going to cover it up yet. I'll do the panels later. For now, I will cut these zip ties, though. All right, so we're pretty tidy. It's not the best wiring job I've ever seen, but it's pretty darn good. I used to have a wire shop. I mean, most places that I've worked, they have a wiring harness shop, and they do immaculate work. This looks pretty amateurish, to be honest, but it's nice enough for what it is. So, the real question is, did I wire any of this correctly? I didn't have you guys double check my work, so it's not on you if everything bursts into flames when I plug it in. Which, you know, that's always a solid possibility. Last thing I'll do is tidy up this bit of wiring up here. We'll flip that around. There we go. We'll just tighten all this up somehow, and then we can move on to more important things. All right. Zippity-doo-dah. What do we do with all this extra wiring here? I guess I'll just bundle it all together. I mean, what do people normally do on these type of Voron builds with all this extra crap? I mean, it doesn't actually flex at all because all of the bending is happening over in the... let me elevate your viewing position a little bit. Because all the bending is happening right here, So really you don't see any flex in this stuff. So someone's saying zip ties. I will gladly zip tie all of these delinquent wires. Alright, unzip tie. I like to bundle all the wires that are going into these type of connections together. They kind of all act as, it's like a strain sharing, if you do it right. They all kind of share the strain instead of, it's not a strain relief, but it at least causes them to kind of all be loaded together. Man, there's not a nice, neat way to do this. I am a little worried about these sharp edges here on the T-slot, and if the wires find a way to grind up against that, that won't be good. But I don't think it'll be too much of an issue, especially if I just encapsulate everything along the outside like this. Yeah, you guys aren't moving anywhere. Okay, maybe throw one more zip tie. Ooh, we've got a nice little tie motherboard. Nice. Okay, that looks good. And this stuff can be tied in right there. Just want to provide a little strain relief for these cables because I don't want them to accidentally get yanked on and cause an issue. Okay. Alright, I'll tuck that up in there. Oh yeah, that's nice. That's the stuff. Okay, that looks pretty good to me. Oh dang, I missed out on the motherboard product placement. Look at that. Okay. Okay, what's next? I think we're ready to turn it on. Who's ready to see the sparks fly? Okay, let's do it. All right. I wired this up about, let's see. It's been many months. It's probably, I mean, it's when the last live stream was. Let me check that. My videos. Last live stream on this topic was 5 months ago. All right, I had a bunch of travel. I was away from the office. And I'm pretty sure I hooked things up correctly. So we're just gonna, I mean, what can you do? You just gotta send it at a certain point. So we're just gonna plug it in, let her rip. Or let her smoke. I hope everything goes well. One last thing I need to do. Let's see. Alright, I was just checking my battery status. Oh no, things are frozen. Hopefully they get unfrozen in a second. Oh gosh. Oh gosh. Come on. Come on. Things have become frozen. Oh no. How do we become unfrozen? Ah, there we go. Okay, we're back. Sorry, guys. All right. It's time to plug it in. This is what we've all been waiting for. Yes. Yes, it's showtime. One last cable needs to be installed. That's for the screen here, so I'm just going to get that wired up. It's one of those flat ribbon cables, so I decided to save it for last, just because those are notoriously fragile. They always get broken, these little things. So I'm going to get that wired up. It's actually not this one, it's a different one. Maybe this one's for a webcam or something. Not entirely sure. There's a short little cable. We'll figure it out. Okay, so is it this? Yeah, I think it's this. All right. Okay, so cable goes in over here. I absolutely hate these ribbon cables. When I was working in robotics manufacturing, you know, back when I used to build robots, literally, these were like the cause of 90% of the problems with a lot of assemblies. Because they're really difficult to get people that plug them in correctly. It's not like an HDMI port where, you know, if you can plug it in and you have a pulse, you probably did it okay. Or like a USB Type-C port. It's basically designed for you to not know what you're doing and make electrical connections. See how this goes. That's plugged in correctly, as far as I can tell. We're going to loop it back through here. Alright, and I'd like to do a little strain relief with capped on. But I think we're okay with it, just leaving it for now. I would actually prefer what Prusa does on their printers. They always use like larger format cables, even though technically you can get away with using these. I just think these are just way too fiddly to use on machines that lay people are handling. But we're gonna do it like this. So I'll plug it into the display port here. All right. Okay. I'm going to get these cables that are hanging out down here out of the way. I'm just crossing the T's, dotting the I's, making sure we got everything good to go. I'm going to tighten this down so it's not so wobbly. Now, I'm just kind of delaying the inevitable at this point because I am nervous about what's going to happen when I turn this on, but that's just part of life. It's part of owning a Voron. Sometimes you just got to take that leap of faith and see what happens. So I'll just get that tightened down so I feel like it'll make me feel a little better. Alright. Alright. Okay, it's do or die time. I'll put 2 more zip ties on the cable up here just to get it to behave a little bit. Don't judge me. I'm just nervous about what's going to happen. Okay? It's okay to procrastinate and delay the inevitable just a little bit as long as you got something to do. I'm just making sure everything's neat and tidy before we have to have a Viking funeral for this thing. Oh crap. Broke a zip tie. There's no way that was my fault. Okay, that's tucked away. I'm just, getting this core XY stage, cable chain management, just to be super nice. So what am I supposed to do? Just fire this thing up? Is there anything I'm missing here? Do I need to do like a prayer, a special Voron ritual? I feel like there's one little bracket thing that I'm missing, but that's not too big of a deal. Everything's plugged in. I think we're ready. Okay. Who's ready to see what's going to happen? Place your bets. Is everything going to work perfectly when I turn it on? You gotta say don't catch fire 86 times. Okay, I'll say it twice. Don't catch fire, don't catch fire. 86 times is a little excessive. Although I can understand why that ritual might be a thing. Am I missing anything? Let's give it a once over, okay? Okay, hold on. Flip around camera. Okay, the camera doesn't want to flip around anymore. That's all right. So we have the print head. As far as I know, I wired everything up in there and hooked it up to the board up here. I'm not 100% sure that I plugged in the stepper motor to the right spot, but it's basically the only spot that wasn't for something else. Nobody's excited for this Elegoo Centauri carbon, okay? We'll just get that out of the way right now, all right? The LED lights are not in there. Paul, you know what happened to the LED lights. They're over there in the corner. In shame. Okay. All right. We got the cable for the whole board, special board that handles this. It's plugged in down here, and that's like managed in the Klipper config. I'm hoping this comes pre-flashed with Klipper. I probably need to plug in the micro SD card, so let's do that here. Pretty sure I saw it in one of these boxes. Here we go. I'm not sure if this is pre-flashed, given the fact that it's like sealed in this container. Leads me to believe that it hasn't been flashed. No, not great. Where would that go? Probably in the Raspberry Pi. Doesn't the Raspberry Pi take a micro SD card somewhere? Yeah, right down there underneath. So let me... that sucks. I have to flash the micro SD card to get Klipper on here. Alright, I guess we can do it. I can do that on the computer here. Upside down. Okay, well, we'll get that going. Alright. Oh, do you want to watch the whatever the heck this is? Thinker X400? There you go. Keep an eye on that for me. Make sure that, let me see if I can flip this around. Yeah, I'm stuck using the front-faced camera that is mirrored. Oh no, no. Okay, hold on. Hold on, we gotta take a little emergency break here. We spilled ramen noodles on the Thinker X400. I'll be right back. I gotta get some napkins. All in the day of accelerated wear testing in the Nathan Builds Robots lab. Ay, yikes. Oh no. Okay, enough lollygagging around. We need to get this done. All right, so I'm gonna flash the firmware, and then does the main board need to be flashed as well? Like this thing, does this have a micro SD card that I need to install? Or will this thing flash that thing for me? Duh. Okay, I just dropped the phone. Okay. Okay, let's see. Does anyone know about this stuff? Mm-hmm. I don't see where an SD card would go. This is the Leviathan 1.2. Oof, I broke one of these little things here. That's probably from the phone falling on it. One of the little parts of the plug. That's all right. I think that's it. That seems odd to me that there's no SD card for the Leviathan. I guess if it's designed to run on the Raspberry Pi at all times, it doesn't really need it. Okay, looks good. Ah, wow, you got zoomed in a lot. All right, sorry about that. I'm gonna wipe off the screen. Okay. Okay. Because if it's LDO, it ain't flash. So you have to flash something to... Alright. Alright, let's go to LDO and figure this stuff out. LDO... Build notes FAQ. Let me check the wiring. I actually should check this wiring guide real quick. Just so I don't do something incredibly stupid. I'll stick with moderate stupidity for my live streams. Okay, part cooling fans, tool head cable, microfit, extruder motor on the reverse side. Okay. This doesn't look like what I installed. Yeah, it says reverse side. Yeah, it got flipped around to the back side. And I'll just make sure that that's plugged into the right thing. Oof, that doesn't look like what I have at all. But that's fine. That's not what I have. I have this. Don't have that. Oh, I haven't actually plugged in this clicky probe, Z-stop. So where does that go? Yeah, that's what I was supposed to do. That's good. Insulating the Z probe. Our kit comes with a small strip of glass fiber tape. It helps insulate the Z probe from the radiative heat from the hot end. Okay, I haven't plugged in any wires. I don't care about the lights right now. Do not change the voltage selection jumper from what is shown. Mixing voltages will damage the octopus. Okay, I don't have an octopus though. Oh, Rev D? What? No, Rev... Voron Trident. No, Evermore. Guides. Rev A, Rev C. Printed parts guide. Rev D. Assembly manual. Cookie probe. Alright, yeah, I have no Z-axis offset. Let me pull that part out. That is possibly important. I'm going to set this up with sensorless homing, so that's something that I'm not going to have to worry about, running those Z and Y end stop cables. Sensorless homing will be just fine for me. But what I do need is I mean, do I really need the Z clicky probe thing? Let me show you what I have. This thing. And what is this? It looks like there's two of these. What? Why is there two of these? 4 pi 5. Okay, I have a pi 4B. What's the difference? Why? Okay. So this says 4 pi 5. I have a pi 4B, so I'm assuming that this was the wrong thing to have plugged in here. I'm going to unplug that. We'll plug this in instead. I have no idea what this thing's for. I assume it's to power the Raspberry Pi. But do I plug it in like this? I definitely don't want to run this in the wrong orientation. What do you think? Is this plugged in right? I could also rotate it 180 degrees and plug it in like this. Right. I have a feeling it plugs in like this. Just because I feel like it. Know what I mean? So let's see, 5 volts goes to this pin. Man. Yeah, 5 volts goes to that pin. We need the multimeter or documentation. Yeah. What documentation do I need for this? Guides. Wiring guide. Okay. Okay, so there's that stuff, and then there's also. Where is it? Z-stop. Okay, so there's this, which I assume gets wired up somewhere. Here's the Z-stop cable. Here's the Z-stop body. Then there's like an actual little PCB. Here's the clicky probe, which I don't think I need because I have the inductive probe. Here's the Z end stop. So that goes in here. And then where does this get bolted to? This gets bolted somewhere. Nathan, screen with eyeballs. Okay, what? What do you need, Mr. Okay, let me just get caught up to live with this. Okay, oh crap, Okay, scream say Nathan at screen with my eyeballs. Know he can hear me. Scroll down and the second Raspberry Pi image shows the correct location to insert the adapter. Okay. Oh, the guide you linked. Neil, did you email it to me? Polymorph, yes. Thank you for the $10. This has motivated me to do the thing. Okay. What are we doing? Scroll down and the second Raspberry Pi image shows the correct. I do need some snacks. I should probably do that. Alright, let me grab some snacks. I'll be right. But let me see what. Where is it? Okay, there's a Raspberry Pi. That's not the controller I have. How far down do I need to scroll? Okay, I might have been emailed by what's his face. No. Discord message? Yes. Oh no. Where's the glorious wisdom that you are providing me? Mr. Neil Lund. Please check the guide I linked. Scroll down and the second Raspberry Pi image shows the correct. It's in the chat. Okay, I'll scroll up. It might have blocked your comment and prevented the link from going in because of the link thing. Link. Okay, yeah, just send me a message on Discord. I'm gonna grab a snack. I'll be right back. Snack time. Polymorph sorters. Okay, where were we? I've got apple juice and, no, it's fruit punch. It says it's 100% fruit. So, actual fruit. Very good. Didn't block it my link to the Klipper. Did it block your link to the Klipper guide too? Yeah, I think so. Yeah, if you send stuff to my Discord or email, Discord's probably better because it's a little faster. This whole time Neil was like, he's not listening. I can't listen. Okay. So Lost in Tech sent me some stuff about Klipper installation. And we're still waiting on other advice. On the correct location of the Raspberry Pi. Yeah, good point. I should be able to turn this on if everything's wired up correctly. Yikes. Okay. So I need the Z end stop. I'm okay with figuring that out later because, like, honestly, if I messed up some of the wiring horrendously, it's not going to matter either way. I've got this. I need the little peg that goes in there. It's somewhere around here. Got my LED light strips. Those are going in another day. Okay. Let's see if I've got any more random parts about the office. Around about. Okay, this looks like it might be important. Trident Motors. Trident Kit? No. That's just filled with benchies. Disappointment. Oh. Yay. Ah, crap. I just bought one of these because I couldn't find this. And it's right. Hold on. I'm gonna return this to Amazon. I just bought one of these. And while looking for my Voron parts, I found the one that I already bought. So I guess I'm gonna return this. It was only 30 bucks on Amazon, but I don't need it anymore. I'm just gonna send it back. Whoops. Okay. Okay. Alright. $3 on this stream by finding things I don't need that will be returned. Oh man. Do I really need that Z probe? Because I have the inductive probe up at the top. Like, what's the point of the whatever this Z thing is? Do I actually need this? I think not. Isn't the Z probe for the bottom position? How many hours till this project is done? Over 9,000 probably. That's about right. I got my juice. I got my strawberry applesauce. Yes, we're having snacks like it's a Little League soccer game, and we're not keeping score, but we're having fun, and we're getting snacks and Capri Suns. Alright? That's the vibe we're going for right now. Okay, Neil. Finally, sent on your Discord under the name I Was Curious. Got it. Thank you. Okay. Raspberry Pi mounting. Okay, yeah. Thank you. That is very helpful. We are now able to plug this in the correct way without exploding the Raspberry Pi. So that's good. All right. So the next question is, do I really need that Z-axis switch? It doesn't seem like it's useful. I guess it's useful if you have a power out recovery situation where you need to home the bed afterwards. Why can't they just use a normal limit switch like everyone else? Instead, they have to use a precision shaft stuffed inside of a collared stepper motor with a little Z end stop switch attached to it. And where does it even go in the whole printer? Like, does it get just to get attached over here? Do I put it like on the bottom here or something? I don't know. Seems sus to me. All right. Okay. Got that in the right spot. Alright. Raspberry Pi software. Alright, we need Raspberry Pi OS. Oh my gosh. Does this thing have to get on the internet? Like, I probably need to do sudo apt-get and all this stuff, get Kaiua installed. Is that what I need to do? I was hoping I could just image all this stuff onto it without, you know, hooking this thing up to the internet. Mm-hmm. Alright, so here's what I'm going to do. I'm going to plug this in and see what happens. And that way we'll know if we did our wiring correctly. So the best way to test your wiring is plug it in. Alright? And the Raspberry Pi should be fine. Everything should be fine. It's time. It's now or never. We are taking bets on what's going to happen, though. What do you think's going to happen? Turn this off first. Plug this in. All right. So everything's going to work exactly as planned. It's all going to power up. There's not going to be any magic smoke release. Right? I hope so. Alright, let's go. Power on. Looks good. Looks good. Everything appears to be going to plan. The heated bed is staying cold, so it's not like short-circuited or anything. Turned on. All these, the Raspberry Pi's lit up. Probably just needs a SD card plugged in there to make sure that it's working. I'm able to move the stepper motors around, so there's not really anything going on there. Hot end is cold. Fans are all off. Cool. All right. That's a good sign. Okay, we'll turn this back off. That's good. All right. So, wait, let me turn it back on one more time because I'm curious if any of the lights on the tool head will light up, which would be a good sign that we're getting power delivered to that thing, which is then delivering power up here. And it doesn't look like we've got any LED lights up there. Maybe I don't know. Oh yeah. No, there is an LED light up there. We've got power. So power is going everywhere that it needs to go. Nothing is fried. That's good so far. I'm wondering if this has an LED or if the LED is only active when it's being triggered to turn on. Oh, good. Okay, let's turn that off. Okay, so that's a good sign. What else are we going to do? Now it's time to flash the Raspberry Pi and get that turned on, so that we at least know that's working, and figure out what do I do with this limit switch. So I guess I'll plug it in. Plug it in. There's probably a bunch of parts that go onto this. I really don't want to deal with it, but I guess I have to. So, I guess I'll just deal with that in a little bit. Alright. Raspberry Pi Imager. Download for Mac OS. Boom, we're doing it. Alright, Raspberry Pi Imager. Get that little SD card. A PAL. Get a little SD card reader. Plug that in. Of course, I can't find an SD card reader. Hopefully they have one in the box. SD card reader. Micro SD cards. Why do we still use micro SD cards? Someone explain this to me. Okay. Okay, we've got an SD card reader. Bingo. Plug this in. Plug that in to the computer. Now we're running Raspberry Pi Imager app. Raspberry Pi OS, we recommend Raspberry Pi OS Lite, Legacy, Bullseye, or similar pre-configured Mainsail OS. Alright, I would like to use Mainsail OS. Please verify you can remotely connect to the Raspberry Pi using SSH. I think it'd be fun to build an LDO Trident. I've only built 2 Vorons, Fistech, and a Cyborg 2.4. I mean, it could be fun. It could be fun. Okay. I'd like to install a pre-configured image like Mainsail OS. That sounds good. Pre-built image for several single-board computers. It contains pre-configured software. You need to run Klipper and Mainsail as your web GUI to control your 3D printer. Okay. I'm down. We're doing it. Raspberry Pi 4. Huh? Supported hardware? Supported hardware. Raspberry Pi. Raspberry Pi 0, 2, 3, 4. Okay. Yes, this is what I can use. Let's do getting started. Raspberry Pi OS based SD card and Raspberry Pi Imager. Download and install Raspberry Pi Imager. Insert the SD card. Choose OS. Select other. Okay. I can do that. Okay, Raspberry Pi device. storage, yeah. Choose OS. Okay, Raspberry Pi device, Raspberry Pi 4B. Choose OS. I want Raspberry Pi OS Other. Special Other Specific Purpose OS. Other Specific Purpose OS. I'll show you guys what I'm doing here because, you know, it's interesting. Some would say. All right. Okay, so we got, I'll just show you. Raspberry Pi Imager. I installed it. Chose Raspberry Pi 4. We want to go to Other Specific Purpose OS. Interesting. I guess there's like a lot of robotics applications that use Raspberry Pi. We're gonna pick 3D printing, and we're gonna pick Mainsail OS. And I'm just following the instructions here. And I selected the USB storage device. Next, would you like to apply OS customization settings? Ensure to set your Wi-Fi credentials. I'm just going to plug this into Ethernet, so be sure to enable SSH. This should be set by default, so I'm just going to ignore that. Okay. No. Yes. Password. All right, there we go. Cool. All right, that wasn't too bad. All right, we're coming up on 10 hours. How does it feel? We're so close. The printer turns on. Most everything's wired up. That's actually important, except for the Z-stop limit switch. I guess I can wire up the X and Y end stop limit switches, but for getting started, I'll just run it with, what's it called? I mean, it like bumps into the ends and it knows where it is, that kind of thing. I guess the limit switches are probably a little bit more accurate, but I don't really care right now. Sensorless homing, yeah, that's it. The chill guy knows. Let's see what's going on in here. Hurry one. Printing away. Again, this is a pretty slow print setting. I'm not overdoing it. I'm not pushing the limits of this machine for the first job I'm having it do. But hopefully I'll get a useful print out of it in the end. Okay. Alright. Alright, so it's 25% done writing the Raspberry Pi image. We'll get this set up and plug it in the back using Ethernet. Alright, writing 42% done. I'm going to try and figure out what to do with this Z-stop and stop thing. There's some really specific parts somewhere that I need to plug into it to get it to work. Here's the pin. So this goes in here, then it clicks. Alright, and then there's some screws I need to insert. I need M4 screws. I think I need an M4 grub screw. Yeah. There we go. Alright, I'm turning to you guys for moral support. Can I do this? Is this possible? Oh, if you haven't yet, hit the like button. Yes, that will help. Within special... Okay, I found the 3D printer OSs. I just need to find one of those Allen wrenches. They used to be so plentiful. Now they're all gone. There we go. I'll put this in here. Hopefully that makes it so that, yeah, now our little probe is captive. It can't be pulled out. And then we need to get some tiny little screws to put into down there. Probably these ones. M2 by 10 self-tapping screw. Yeah, that looks like it's the right thing. Get 2 of these. Alright. Alright, we got this. I think LDO included this special screwdriver just for these screws. Very nice of them. They probably realized this step is awful if you don't have a good screwdriver, so they're just hooking you up with some nice hardware. Very cool. Okay. One down, one to go. Alright, and then does anyone have any idea where this is supposed to go? Like, where does this get attached in the grand scheme of things? Is it upside down under the bed? Like off to the side here? What does it bump against? Is it attached to the side? Maybe down here? Yeah, I don't know where it goes. So it's supposed to go in the back of the heated bed. You can change the position on Klipper. Okay. So does the nozzle touch this? Or does this touch the bottom somehow? Like a nozzle? Okay. Ah. Okay, I see. That makes sense. And that's why there was 2 unused T-slot nuts back there. So I'll get those, get 2 more of those M3 T-slot nuts, and get this put in position. Alright. Very easy. Easy does it. Oh no. That's one more thing that I need to run into the cable chain. That's not a big deal though. I'm a pro at this point. Oh, here's another thing I like about the Ender 5. Look at all this desk space I get underneath it. It doesn't take up all this space. I can use it for storage. As long as you don't pile up things above the top of these, well, I'm actually doing it already, which I'm not supposed to. But as long as you're like kind of flat on here, you can use that area for storage. Although you do want to be careful because there's the cables and stuff down here, but you know, I'm working with limited space, and having that extra desk surface space area is useful. So let me get my, plug in the camera, aka my phone, and I'm going to get that cable run down the back. I just need some M25 machine screws. No, M20s, M16s, M3x16 I mean. We'll see what we need. Nope, longer than that. Probably 25. M3x25. We got 2 of these. Yes, that looks like it will work nicely. All right. Alright, I've installed the little Z-probe point at the back. Alright. I got those screws. And now I've got to add that cable to our little thing here. I thought I was done with, but you know, sometimes you gotta go back and revisit the things. Okay, got the nozzle touchy thing. Somehow this is tangled. I have no idea how this got so tangled. Let's unplug it back there. Get this sorted out. Come on. Alright, untangle away. On page 180, the Voron Trident GitHub, there is info about the probe if needed. I think I'm good. I just need to plug it in and get it wired back there. So that's basically all there is to do. Get that plugged in. And get it wired into the back. I'm going to give it a little twist. Twisting up your cables typically makes them behave a little better. Sometimes I'll get a power cord and a power drill and give them a nice twist so that they stay coupled together really tightly. But even just a little twist can make them a lot more manageable. And I'm just going to open up all of these cable. These little cable chains and run this through. There's no shortcuts here. Okay. Uh-oh. Sometimes you have to refresh the live stream so that it doesn't eat your entire system memory. Like it just crashes every now and then. Alright, here we go. Oh yeah, woo! We're up to 92 likes. Awesome. Oh man, it's almost midnight. What am I doing? I drank like 8 8 shots of espresso in that water bottle. You saw the nasty coffee goodness that was in there. I don't think I'll sleep for a week. Alright. Okay. All done with that. Alright, and that can go down there. I think what I can do is have this kind of up there and run the cables down through back. And along down here, down into that little hole. Now we'll get some things to help hold them in there. Holy moly. Zip ties. All right. Glorious, looking glorious. Okay, that's another job well done. Raspberry Pi has been written to the SD card. Time to remove it. I'm going to plug it into the thingy here. Okay. All right. Got those zip ties. All right. Job done. Okay. If I say okay enough, I think the printer will be finished. Okay. Alright. Okay. Get that. Got tucked away in there. You know what would make this stream more entertaining? Story time. Yep. That'd probably make it more entertaining. That's a fact. Okay, we got our Z probe all wired up. Okay, alright, Z stop is installed. I'm going to plug in this little SD card. Holy moly. That's good. Alright, so now we're all plugged in. I think it should power on now. And we might get like a little Klipper screen thing, a little Klipper screen action. And we got that little Wi-Fi router, which I'll have to switch my computers over to, which means that I won't have internet on my computer, but I'll still have streaming on my my phone going. So let's do it. The time is now. Alright, so SSID key, device, etc. Okay. Here goes. We're losing internet. We're going dark, guys. At least on my laptop. Oh, my computer remembers this little router because I logged into it a long time ago. Alright, and how do I log into... how do I get this computer to talk to this thing? How do I know the IP address? Maybe I turn this on? Z probe. Good. All right. Are we in business? Did I unplug the thing? Please don't tell me this thing is not working anymore. That would suck. Power. We're at 115 volts. Power on. Wait a couple seconds. Come on. The 24 volt line keeps turning on and off. It's not a good sign. Okay, that means the thing might be detecting a short circuit. I don't know how that could have happened. All I did was plug in the Z probe and give the thing here an SD card. I didn't really change anything. I mean, the cables have enough flex in them that it shouldn't be an issue. I plugged in this Ethernet. Can you unplug that? Nope. Alright, still flickering on and off. What did I do? Ground and power. Oh no! Yikes. Z probe. Bad. What? Why would it do that? Okay, well, let's see. Alright, everything powers up just. Fortunately, the whole setup is smart enough to realize when there's a short circuit, and it protected itself, I think. I don't know if I plugged in the screen correctly. It's not powering up at all. I might have installed the ribbon cable backwards. So I'll try flipping it around. Okay. Alright, let's see if the screen powers up now. Oh, wow, there's 2 layers of screen protection. Alright, so yeah, that ribbon cable was plugged in backwards. And now it's upside down. Hopefully there's a way to flip that. Ah, crap. I probably just installed it upside down. I'm sure there's a way to flip that 180 in software. Okay, this is good. It's booting up. Wow, I'm glad the short circuit didn't instantly destroy everything. It just kind of turned on and turned off and turned on and turned off, and it's like, I don't think I want to self-destruct, so I'll just slow down a little bit. I'm going to check the chat on my phone because my computer's now in the mode where it's just going to the printer. Check the live chat. JL, how long did it take to build? Story, I built my Poly Maui years ago, but never put resin in it. Ran for the first print ever a few weeks ago and destroyed the silicone vat. Nice. Once upon a time, and they lived happily ever after. There you go. Did you get your first snow yet? Yes, we have snow. I've seen all the snow in the last couple months. On page 159 of the Voron Trident GitHub, there's, oh yeah, info about the probe. We're good with that. We're good on that. All right. So now it's asking for a login. Main Sail OS login. Well, I don't have a keyboard on here. So what do you expect me to do there? What's the big idea here? Do I need to SSH into this bad boy? Is it time to SSH? I can try. Ah, crap. I can't look up help because, you know, the whole lack of internet thing. I'll just switch back to the Wi-Fi. Open up terminal, type a command in the format SSH. mainsailOS.local and press enter. Okay. We got the file. Now it's time to enter the terminal. Nice. We've logged into the SSH. We're mainsailed. Okay, now what? Let's see. Raspberry is the default password. Okay, I don't know what's going on now. Okay. Okay. This should be working. Okay, well this isn't working. There's probably some dumb, like, Mac specific thing where you need to like enable some crap. Because when I type SSH hi at mainsailOS.local, it just freezes. And on this screen, It's like stuck. Well, actually, maybe I'll put you upside down for this. Oh wait, it's backwards as well. Yeah, that's not... You're gonna have a hard time reading this. But it's stuck at a point where it says mainsail OS login :_ flashing. Like it's expecting me to type something here. I can't type anything on there though, because it's lacking a keyboard. Threw away the LEDs. And it looks like it should print now. It looks like a 3D printer. It's ready for business. We're ready to print. However, at a certain point in life, you decide you need to go to sleep, or at least go home. And I think that time for me is now. So I really appreciate everyone. I mean, this was a pretty well attended live stream, and I think we had a little bit of fun. We watched the Uri one X400 do its thing for a little bit. That was fun too. Didn't do anything with the Creality Ender 5 Max. That thing is super loud, so I don't think it would... Oh no, Pezlas wants a refund. Oh no, how much did she pay? Oh no. This is gonna financially ruin me. She's pulling out the carpet from beneath me. Chill Guy, thanks for joining. One Bernaner. Yes. $3.99? Oh my goodness. I do feel bad about that. I mean, you only got 10 hours plus of live streaming for that $3.99. If only there was some way that I could make this all work out. But I just think that it's time, you know, to call it quits. Maybe we'll pick this up tomorrow, figure out all the software stuff, bring some... I'll get some, like a keyboard and mouse and stuff, and do some business on this thing and get it running all the way. But and also I need to figure out how to wire up the Z end stop switch so that it's not causing a short circuit. But thank goodness they're using a genuine Meanwell power supply that knows how to not self-destruct the entire printer. That's pretty good. I appreciate that. So, good job, LDO. If this was a cyborg kit or something cheap, I'm not sure if this would have been good for anyone involved. There might have been magical smoke release, but thanks to the genius of the Meanwell power supply, we're able to avoid certain disaster. Not sure what else to say other than thank you everyone for joining. Your moral support was essential to getting this far. Kept me on task, and also the coffee was probably played a big role in it too. But yeah, okay, thank you everyone. Hope you're yeah, Zombie Hedgehog. Yes, if you guys are looking for something else to do, look up Zombie Hedgehog on Twitch. It's always a good time over there, but for now I got to go. Again, thank you everyone, and we'll see you in the next live stream / episode of Nathan Builds Robots. Bye-bye. Bye.